Everybody, today is Tuesday the 15th of August, and welcome everybody who's watching in the chat room, and welcome our lovely panel. Today we have Mark Sargent from USA, Chris from Canada, Thompson from America, Series from Holland, Stan UK, Turquoise Dragon UK. Good evening everybody. Wave. Yeah, it's really nice, and we should have Mike and Dave Marsh joining us. Anyway, so good evening to all of you. How are you, Mark? We were just talking about with Patricia outside into the museum.
Oh, the museum. The Museum of Flight down in Seattle, Washington. I am just north of there by about 30, 40 miles, and the idea just came to me. She's going, what can we do while we're here? Because we had already done the meetup on Tuesday, which was downtown Seattle, and that was a lot of fun. We had over 50 people and great turnout, a whole bunch of people. They had to kick us out of the restaurant. The restaurant closed at 9. We went from 7 to 9, and the cleaning crew was already coming in. And they at one point, the manager at the very end came to me and said, "Look, you got to get out of here. The place is we're literally locking the doors. All the chairs are already put up on the table." So we went out to the parking lot, and there were still 15 or 20 of us out there when I left, because I had to catch the last boat home. But it was a lot of fun. Anyway.
It's really nice to be out with people, isn't it? And do it outside, just going outside and doing it. And the Leamington Spa one was really good. And we felt like little children, I think.
Sorry, you were breaking up just for a second there.
Oh, I said in Leamington Spa, you feel like little children outside.
Oh, absolutely. With the enthusiasm, I encourage anyone to do a meetup if they can, because the enthusiasm when you're there, for a lot of people, I mean, this one was my 5th, I believe, but for a lot of people, it's the first time they've actually been with somebody else that's on the same page as them, and your energy levels are just off the charts. There's no disagreements in the room. Everybody are just excited to be there. They're, the camaraderie, not being persecuted by anyone around you. I kind of joke about it, but it fits, and it's kind of like a happy version of an AA meeting. It's really how it starts. It's like, hey,
I suppose that's a way to put it.
Well, it's true. I mean, you go there. I mean, I've been in quieter ones. I mean, the room was so loud, but you go to quieter ones, and it's like, yeah, my name's Mark. I'm a flat earther. And everyone goes, hey, Mark. Some applause, and then you tell people about your journey. How'd you get there? There's a lot of common questions. Everyone tries to catch up with each other, and it's a lot of fun. Anyway, so that was Tuesday, and it was just a blast. I again highly recommend. I'm so happy that people are doing it in different cities all over the place. But we wanted to come up with something. Is like, okay, what else can we do around here? And since we're up in Seattle, that is the headquarters for Boeing. Boeing Aircraft, and they are a major contractor to NASA. And so the Boeing Museum of Flight is very extensive, and they have a fantastic space exhibit. So we decided to take a trip down there and buy some tickets and go on in and see what we could see. And it was amazing. You guys watched the video. I mean, it was amazing, the programming. Yeah, one we were just super excited to be in there, and we didn't want to accost too many people. Patricia approached one of the tour guides initially, who was just kind of milling around. He didn't have a particular group with him, and he thought, of course, that that the flat Earth community was insane. But then he apologized almost immediately afterwards. He was a guy probably in his late 60s, early 70s, and he was saying, "I'm sorry for being so abrupt." Kind of like, I don't know what came over me. And I knew full well what came over him. It's like, that's the knee-jerk response to it. But then he talked about one of the local athletes here in Seattle was on board with it. Anyway, so we went around. The gift shop was whole. Had a massive space section, total programming. But what I thought was interesting, I really didn't figure this out till the end after I'd gone through the entire thing. And they do have a cool Apollo exhibit. Lots of mementos from the American space program. But what was interesting was the reason it works. I just kind of dawned on me the reason why space programming works so well in a place like this. And there were a ton of kids there, a lot of kids milling around. Because this is a field trip type place. You take a busload of kids, put them. You put on all the kids wear the same T-shirts, so you know where they are. But the reason why it works is that you're mixing reality with fantasy. Sort of like Oliver Stone when he did JFK the movie. He caught a lot of criticism for the government because he was mixing authentic footage with his own footage. And when you blend them together, you don't know really what's real and what's not. His interpretation worked, and so he convinced everybody of what we knew was true. But when you're showing people airplanes, we've all, at least I can't speak for everybody on the panel, but if you've ever ridden on an airplane, airplanes are real. real. And I see them flying every day and go down to any airport. And when you mix that with the space program literally side by side and show, oh yeah, here's an airplane, here's a spacecraft, here's an airplane, here's a spacecraft, here's a spacesuit, here's a flight suit. Once you start blurring those lines, there's almost nothing you can't do. And so it's going, of course the kids are going to buy it. Heck, I'd buy it. I did buy it for most of my adult life. And why wouldn't I? You've got it all right there in front of you. You can touch it. It's like, oh, look, here's his FR-71. Here's a Mercury space capsule, literally within a rock's throw away from each other. And it wasn't sad in a way. It was sobering in a way, because then I understood how easy it was for the powers that be. People say, well, you couldn't fake a space program. It's like, of course you could, because most of it is just mementos of days gone by. Nobody knows any astronauts, of course, there's a few astronauts still out there, but you can go to any of these major cities and, like Houston, we're planning on doing that next, is actually going to the NASA Space Center and going to the big museum down there, because they got tons of exhibits down there. But this one was pretty significant. And to see it all right there up close, you understood how easy it is for stuff, even though you don't, but we can see it. Like the moon buggy was a perfect example. I did not know that the official moon buggy, even though all the training missions they did down here were using rubber wheels, I didn't know the official moon buggies had metal wheels, because when it's shot, the way it's the photography is set with that gray ashy background, it just took in the color of the background behind it. So everybody thinks they're rubber wheels, but they were metal. But the point is, you're looking at the moon buggy and you're saying, oh wow, it's cool, it's on the moon. It doesn't occur to you how it got off the Apollo program, how it got off the capsule and all this other stuff. Anyway, it was fascinating. Highly recommended for anyone to go there and to any one of these museums scattered all over the place and see what propaganda can do. But again, the key is to mix the obvious with the not so obvious. Put a biplane from World War I, right next to something from the 1960s. Some sort of space memorabilia. It's brilliant. Anyway, that's what we did on her last full day, and then she took off the day after that. But it was a blast.
I remember when we went to Leamington Spa, the parents everybody was in love with space. It's like, look at the rocket. It's all like everybody's
Can I comment? Can I comment on that real quick? That's interesting you would say that, because I never understood. Being in America, I completely understand how people buy it here. Rah rah, wave the flag, go team, America #1, all that jazz, right? But outside of America, and I know there's more dissension outside. A lot more people that don't believe what the Americans did. But it's like, why would any of you believe what we told you? Was it just because we put it in magazines and we were the only people creating a lot of television? Was that it? I mean, honestly, if the Americans tell you something, I'm not, me, I'm not saying overthrow the American government. I'm just saying, look, don't trust the American by any stretch. Not when it comes to the American media. It's like inside the country, yeah, we're required to do it. It's just one of those things. We have to believe it. My own sister, if my sister believes it comes from God's lips to Fox News, and if it doesn't go in that order, it never happened. So, but when we say things like, in fact, let me give you a quick example. North Korea said recently, within the last few years, like that they had sent a probe to the sun or something like that, something ridiculous. And the Americans would be, no one on our side, because they're the bad, why don't you believe it? Well, because they're the bad guy. Oh, so America's the good guy then, because the good guys would never lie to you. Then we start getting to the question of what's good and what's not. So I'm sorry. Anyway, that was my little rant.
It's fine, Mark. Thank you very much for explaining your time out in flat Earth. Today as well, to explain that you're being like, you've got a camera crew that's going to be like with you, and then with you with the Eclipse.
Yeah. The Great American Eclipse is what they're calling it. Again, America #1. It's in America only, and a team out of Los Angeles, Hollywood, has already been up here before. They were here and they were in Houston with Patricia shooting stuff, and then they decided they wanted me to do color commentary on the Eclipse. So they're going to be be here on Friday. They're flying in Friday, and we're heading down Sunday morning because the eclipse is Monday morning. And, first thing, it's like 10 a.m. And it's a fascinating eclipse. I know if you're outside of the country, it's going to be wasted. But it's fascinating because it's the only first time in 100 years that it actually crosses the country like this. And it is going literally from the West Coast, up in Oregon near Portland, all the way across the United States and ends in Charleston, South Carolina. Going to be amazing. So yeah, we're going to sneak in there. We're going to go through the back roads. I know a couple ways in because I'm from here, and it is going to be it's going to be the biggest traffic jam of all time. And the flat earthers have already done a billboard, a research flat earth billboard in the perfect intersection. So ground zero of this eclipse. And the reason why so much media, like all your major, NBC, Fox, NBC, ABC, CNN, anyone in media is going to be in ground zero, which is going to be Salem, Oregon, this little town in Oregon. And the reason they're going to be there is because the media doesn't like waiting for things. So they don't want to wait for it to all cross the entire United States. That's literally the first town on the map of any significance. So everybody's going to be jammed in there. The governor of that state has already declared a day of emergency in advance because there's so many people. Well, you can imagine, right? There's only so many highways. And so, all the hotels are sold out. There's no flights. You can't get in there. And it's going to be, I wouldn't surprise me if the National Guard was called in. Because if you're driving down the major highway, Interstate 5, one of the biggest highways in the country, and you don't know the eclipse is happening, you're going to freak out because everyone's going to start slowing down, and they're just going to pull off the road and get off their cars and just start staring straight up. You're going to think that you're under attack by some sort of alien armada. You have no idea what's going on. So it's going to be a zoo. They're already talking about food shortages. We're taking 2 cars. I'm going to pack my trunk full of emergency food. I'm a survivalist. I'm just going to grab one of the cases. And we're going to stay there that night because the tough part isn't just getting in, it's getting out. So once the eclipse happens, good luck getting out of there because it's going to be a parking lot. How quickly can you evacuate 1 million people out of an area that should only have 100,000, if that? It's going to be amazing. Oh, anyway, sorry. So the documentary team wants me to do color commentary on it. So we're shooting that, and then the same group is also going to be going to the conference in Raleigh, North Carolina in the fall. And that's going to be the big finale. And then after that, I don't know, hopefully they pitch it to Sundance, one of the film festivals. That's what I think they're gunning for. Or to get some distributor. Not exactly sure. All I know is I'm supposed to, wave and smile and point at things and look pretty and American.
It's been exciting though that it's being covered though, like a camera crew is following you because that gets, at least that'll be all over YouTube and it's just part of, I don't think it's good, isn't it?
Well, you know what they say, any publicity is good publicity, and these guys are trying to take a neutral approach. They're not pro flat earthers. They're more intrigued like anybody else that's contacted us. It's like, how is this happening? Why is this happening? Who's involved? So from their point of view, they're curious to see the growth of how it's expanding. And, the numbers just keep growing, going up and up. The relevant search, even since we've last talked, has jumped from, I think, 17.9 to 18.3. That's still, we're leaving Lady Gaga in the dust right now. Still cannot catch Donald Trump to save our lives because every time he opens his mouth, he generates another 100,000 views or 100,000 relevant search results on the internet.
He probably buys them though.
I don't think he has to. Seriously, when has he said anything that hasn't been controversial? Everything he says, it just gets ripped apart by everybody. So it's fascinating. But anyway, it's gonna be a great time. I'm just crossing my fingers. Hopefully the weather doesn't turn south, but we may get lucky because I'm not saying that good things come out of tragedy, but British Columbia, Canada is basically on fire right now. There's just this huge forest fire in the northwest part of Canada, and some of that smoke has been drifting down into the States, and it's causing some beautiful sunrises and sunsets. So it'll help the eclipse viewing for people that want to view it longer and not use the glasses so much. Not that you shouldn't use the glasses, kids. Remember, safety first.
Yeah, Mark says.
Yeah, I know. I'm safe in saying no. I'm sorry. Go ahead.
Dave Marsh has joined us. Hello, Dave.
Hello. Can you hear me okay?
Yes.
Yeah, we can.
Cool.
Oh, carry on.
I was just going to say, on back of what Mark was saying, I'm going to try and catch the eclipse from my location here because it should be available for about 5 to 10 minutes. So hopefully I've got a solar filter now, so I'm going to try and catch it, obviously on the day. And like I say, I'll take up that challenge. What was about saying that we won't be able to see it in the UK. So time and dates, and we're going to see it. So I'll take up the challenge and see what we get on the day, weather permitting.
Cool. Thank you, Dave. As ever, you were out with your camera, so thank you very much. Mark, what's your take on this eclipse?
Sorry, you're asking me? Yeah, the eclipse is, for us, at the very least, is a great opportunity to just generate massive more exposure, higher levels of exposure to the entire community, because it focuses on all the weird coincidences and unusual quality of both the sun and the moon, their relationship. I mean, seriously, if you do enough Google searches on this, I know people are normally lazy. It's like, where will the eclipse be? And, do I need glasses and crap like that? But there's so many weird things that we've been focusing on the community when it comes to the eclipse, not just the eclipse, but the sun and the moon, that it draws more focus to it. It puts a spotlight on these objects that we've been tying to the flat earth for some time now, but it really, like, for example, all those cool little factoids that all the flat earthers have learned, even though they say, oh, we're against science, but we've learned more about science than we ever wanted to. Like the only reason the moon fits exactly in front of the sun is for that weird coincidence that even though it's 400 times more narrow than the sun, it's also 400 times farther away than the sun. That weird coincidence. The fact that the moon is locked into a certain rotation to where we only see exactly one side of the moon, no matter what. It doesn't even change a quarter of a degree over 50 years, which seems impossible. Love that. The fact that, the article that I loved so much recently, let me focus on this, is the Washington Post. If you guys hadn't seen that, the Washington Post video that came out that I kind of tore apart and put little comments on it, and we're talking about science nerds. This wasn't some live thing they did. This was edited. This was the best they got, right? The best people they got from their science department. They're coming out and they're trying to explain the eclipse, most notably, and I know most people aren't three-dimensional thinkers, but most notably why the eclipse is moving from west to east, because it shouldn't it be the opposite, right? And they're stumbling on this. They cannot figure it. They're talking amongst themselves. That wasn't even close. They had nothing, right? So they actually went to NASA because if the Washington Post wants to go to NASA, they do. They went to Goddard Space Center, grabbed one of their chief geeks, and he sits down and he tries to explain it, and he went nowhere with it. First off, his explanation, either he worded it wrong or it was just dead wrong, saying how the moon travels way, way faster than the Earth rotates. I'm going, are we talking in miles per hour? Or are we talking rotation, like geosynchronous, whatever. The fact that it's locked into orbit with it. Sorry, I was screwing up the pronunciation there. Where he said, oh, it travels faster. I'm going, no. And even the graphic was wrong. That's why I had to make a video on it. And you steal the whole thing and just start chopping it up, because the graphic showed the moon literally traveling faster than the Earth rotates. I'm going, where you come up with this? Because mainstream science says that the moon takes 28 days and change to get around one rotation around one orbit around the Earth, meaning the Earth is just moving. We're not talking about RPMs here by the time that thing gets around. So why is your graphic?
Who was it we were talking to, Chris? It's Mach 80. We're going at Mach 80.
Right. Oh, you mean, I'm sorry, with the Earth is rotating at Mach 80 or the moon flying?
The Earth.
Well, I mean, it didn't really matter. The point is that the Earth, for anyone out there in layman's terms, the Earth spins 28 times around by the time the moon gets around at once. And the graphic they were showing was showing the exact opposite. In fact, it was showing the moon actually gaining on it. It's going, and everything about that graphic was wrong. The moon was the wrong wrong size. I don't know what the heck the continents were doing on the Earth. I don't know what perspective they were showing, but the whole thing was terrible. And that was the end of their video, to where they cut back to her and she's going, clearly, we don't have all the answers. I'm going, why don't you have all the answers? You should have it. That's the whole thing. That's what you just did a segment. That's the best you could come up with. How many takes did you do before that you decided that was your best cut? Oh my God, it was terrible. Not to mention the sun.
You find it quite alarming with the year 2017, and we're ripping it to pieces now. Like, we must have just been asleep for centuries.
Exactly. Could not see the same reason why every pilot I have talked to they just now clicked, because we couldn't see the forest for the trees. He's going, yeah, the pilots there, they sit in the cockpit, they go, yeah, we absolutely have wonderful vantage point. It looks flat all the way across, but it can't be, because we're told it's not, right? And it's like, then they get this weird paradox. But
we all did, really. We all got it, really, that we're flat flying. I mean, how come the pilots didn't get it?
Well, you don't get it, again, one, because you're told since you're 6 years old, and that it's a globe, and two, the pilots, remember, their ultimate goal is not to die. So they've all, in fact, it was weird. They all said the same. It's like, look, if we take off from point A and land at point B and nobody crashes, that's a good day. The pilots, they got that weird thing where they say that it's boring with these weird moments of utter terror. When you're landing, taking off is not that bad, but when you're landing, you've got this weird feeling. It's like, okay, don't screw it up. There's a whole bunch of people back there. The other thing about the Eclipse, not to drag this out too much, the other thing about the Eclipse, which they didn't even address in the Washington Post thing, was why, when every other scientific model shows the sun rays coming in, parallel, that they're all just running parallel to the Earth, right? But when they show the eclipse, everything's converging. It hits the moon, and it's like the moon becomes this focal lens for this tiny pinpoint dot. It's like, oh yeah, by the way, that's how you can get a 2,000 mile across object to only cast a 70-mile shadow. I'm going, that's kind of a tough sell, because remember, people are use the Art of War reference. People are like water. They always take the path of least resistance. They always take the easiest explanation. And you're saying, or the moon is really small and that shadow is more like the size of what the real moon really is. It's like, well, no, there's this dark ring around it. I'm going, because you keep talking about these parallel lines, and then you all of a sudden change it for the moon. You say, during this eclipse, there's this little dot going, man. You're doing nothing but helping us, because we're the ones in the first place saying that the moon is really, really small. Yeah, so I mean, and remember, the people they'll try to do practical examples. When we said there was no curvature of the Earth, people immediately started running to the beach in droves with cameras, started taking pictures of things, because that's the easiest thing you could do. Just go to a body of water and take pictures of things across. So what do you think they're going to do in this case? Try to show me something with a flashlight in any object that you have that you can make the shadow really, really small. Everybody knows what shadows do. It's either normal size or it gets longer as the sun gets further, further down in the horizon. So how's that? How you pulling that off? How are you making a 2,000 mile object shrink down? What is that? 90 something percent, from 2,000 miles down to 70 miles? Not buying it. It's because the sun's so far away. Average person is not going to buy it.
Have to make sure it's cloudy so that no one can really see. Make it cloudy with heart so that no one can really see it, because once those P900 cameras come out, it'll be end.
It's a nice idea. However, if you believe in weird coincidences, August 21st, you're talking about the end of summer, and it's across the entire country. The chances of the entire country being overcast, not ever going to happen. Plus, we're talking about, there's a lot of different weather along there. It goes from Oregon to Boise, Idaho, down through Cheyenne, Wyoming. There's no way
it's going to be well.
Yeah,
it's going to be seen really well.
Yeah, and plus, here, let me end on this. What I'm jealous of are the people who accidentally, I mean, not even deliberately, accidentally booked a flight from a commercial airline flight from the West Coast going to the East Coast at that time, because you don't want to bank on it, because flights get delayed, and if you're even delayed by 30 minutes, you're screwed, right? So imagine somebody flying from Seattle or Portland going to St. Louis, going west to east. They're going to watch because you can't beat it, not in a commercial airliner. They're going to watch a slow motion eclipse. A lot of people, there's going to be people sitting in the plane that aren't going to know, and the captain's going to be on going, it's like, by the way, to your right, the eclipse. It's like, what? You know, the whole sky goes dark.
Eclipse happening. He's not. Yeah.
Anyone with a window seat is going to freak out. But it's going to be something. Let me make a quick prediction. This is my bold prediction. Probably not going to happen. Anyone that makes a bold prediction usually gets screwed. But if it was me, if I was looking for production value, I would do something during the eclipse. I would. I'm using the Steven Spielberg method, which is he goes, you do not waste production value. If there's something natural going on that you don't have to pay for, maximize it and use it, and use all your other stuff, because it'll amplify what's going on. If the eclipse is natural and it's gonna happen this way, crank up Bluebeam, flip the switch, turn it into something cool.
Yeah, the mothership's coming in right in the shadows.
There you go. Exactly. Why not? I mean, seriously, it gets dark, everybody's looking, it's being streamed everywhere simultaneously. Do something right then and there. What excuse do you need other than that? I don't know any other events coming down the road. That's what I would do. But anyway, that's just me. Anyway, guys, that's my rant. I've been talking too much. Go ahead and whatever else you had to do.
Mark, we asked you on, and it's good to have you on, and it's good to hear what you've got to say, and it's really good that the camera crew are following you, isn't it?
Well, that and the camera hates me. So. And by the way, it's very uncomfortable being mic'd up, because you have to wear a wire. You have to wear a microphone that's constantly recording. So you're aware at all times that you can't, do the stuff you normally would do, like make bodily noises or swear or make fun of people.
You've got to do a bit of skipping, though. Remember what I said when I came on? You've got to do a bit of skipping.
Oh, my God. You know what? For you, I will skip. I will skip at least once that they get it on camera.
Thank you.
All right.
I'll ask you then, as you've just paused for a moment, we've got quite a few people on with us, and this is an Eclipse talk tonight. I just wondered if each member of the panel just gave their version a little bit of what they think of the Eclipse. And Mark won't mind, because, he can talk and ask questions himself. So we just start with Chris. Chris, your version on this Eclipse, because you've done a lot of work for this. We've done a lot of research in our group over this Eclipse.
Yeah, I've been trying to work with not just my own model and stuff, but with other modelers and, top-notch animators and modelers to try to see, basically pick apart what's being presented in the mainstream media as their animations and models and explanations like Mark was describing, and where they're not getting it right, and where, comparing the two, what is right about it, what's wrong about it, what's, feasible in modern physics, right? And scientifically speaking, can light in a vacuum travel that far? Are there any shadows in space, et cetera, et cetera? I mean, we've taken it right out to the nth degree in diffusion and optics and, particle distribution over billions of miles, or 93 million miles. And it's, we've all came to the same problems, right? It just can't be modeled realistically in any model, whether it be three-dimensional 3D objects in Blender with the proper light sources at the proper scales, whether you're using 4D cinema or virtual reality augmented 4D software, right? Z-Proxy's tried to model it, and we all end up with the same results, right? The shadow sizes don't quite work out. If you like mainstream science will say that light in space travels in straight lines, right? Well, if you make your object shine a light in a straight line like they say it does, which is pretty much a laser, then you end up with a very straight shadow, and the shadow doesn't change its size relative to the object, so you'd end up with a 3,000 mile shadow crossing the face of the Earth. And if that was the case, well, then why doesn't Venus do the same, considering that Venus is the exact same side of the Earth? We should get a Venus eclipse every so often. One would think logically that would black out the entire planet, right? And that doesn't happen in reality. right. And so it's been an interesting adventure, and I've learned probably more about light and optics and angles and scaling things, size and particle distribution systems. And the three-body problem is kind of what Mark was describing. It's even mainstream media, they get on, they try to explain it to the public, and they can't, because it ends up being the three-body model problem, which involves gravity and three orbiting objects. One's constrained. You always have to constrain one to make the other two type spin in the right directions and orbit and this and that. And if the main body is bigger than the others, well, then it slows down the orbits of the two. And mathematically, that just debunks the entire solar system model, because it fails even if you try to use gravity, which we know what gravity is, right? It just keeps, there's one error keeps piling on to the next until the entire thing just becomes so ridiculous that it boggles my mind as to why anyone would even think it's remotely possible in any sense of the word. So I agree. It's been an interesting learning curve over the last couple of months looking at this eclipse specifically.
Yeah, Thank you, Chris. We'll come back anyway to you.
Yep.
David next. You're next on my row of people. Your version of the Eclipse for Mark.
You talk to me, sorry.
Yes, I'm talking to you, Mr. Marsh.
Okay, yeah. So, like I say, I've done nowhere near as much of the of research into the Eclipse, but what I have picked up, like the majority of people, is that to me the shadow going from west to east is simply the line what is required for each person or each observer on the ground to actually see totality. That's what I've gathered from my own, like, looking into it myself. I'm just presuming that obviously each person on that line through the center of America would need to be for each observer on the ground to see totality. So obviously, as the moon moved into position like that, as it moved in, the person there obviously would see totality. But as it moved further past, it would move down the line a bit like a pivot point, really. So as the shadow moves around like that, it literally comes round like a pivot from the sun and the moon. Now, the problems I've seen with it, which everybody says, is the size of the shadow. Clearly, it wouldn't be 70 miles, but also not only the actual shadow cast on the Earth, but the actual silhouette on the sun. That shadow, if you look at it, you see how short that shadow is. Yeah, from an object like 238,000 miles away from Earth, and the sun 93 million miles away from that. To put a sharp shadow like that on the sun, to me, tells me that they must be a lot closer. And obviously, with the size of the shadow, what's being cast on the Earth, then the moon would need to be a lot closer too. And that's my thoughts on it. But like I say, the shadow going from west to east is simply the angle of totality required for each observer on the ground, if that makes sense.
Thank you, Dave. We'll come back to you in a moment. Thomas Thompson, your take for Mark.
Well, my take isn't much different from the last two gentlemen. My big thing is, again, the shadow size. I try to keep it real simple. I try not to get into too many details on this because I can't fully explain the moon at the moment. But yeah, my big thing is how do you get such a tiny shadow from such a huge object so far away? You know, and I think anyone can set up a little experiment in their own room where they're at by setting up, let's say, a flashlight at one end of the room, shining onto the wall at the other end of the room. And if you notice, if you go up to the wall that the light is shining onto and put your thumb on that wall, you'll notice that your shadow of your thumb is about the same size as your thumb. The closer that thumb gets to the flashlight on the other side of to the point that you're actually touching it, you cut out more and more light. Your shadow is going to get bigger and bigger. So I think that's what flat earthers should be concentrating on right now. I think is the fact that how do you get such a tiny shadow? I notice when people are doing experiments and they're sending photographs to me and I'm looking at them, I'm seeing shadows that are larger than the object that's casting the shadow. But whenever I look at a NASA diagram, it's always a cartoon drawing. It's always a computer animated, well, this is how it works. You know, we get this tiny shadow by this happening and that happening. There's this real complex mathematics, and you're probably just too dumb to understand it. So just leave it to us professionals. But no matter how I do it, if I got a convex light in my living room, I can't get a smaller shadow. I can't figure out how they're doing it. So that's where I stand, proving this. I think this shadow proves something's wrong with their system.
Thank you, Thomas. Thank you very much. Series, your take on the Eclipse series?
It takes a while to react. I'm basically a computer with all the rendering. Eclipse. I really don't know much about it, but so far I figured the story what was told yesterday last week with Santos Bonacci of how he explained it through Rahu, and that connected to the astrological chart in how the cycles work, and where you can see that Rahu is actually very close at the moment of the eclipse, and then existing out of 7 bodies, where of one is actually hiding the sun. And apparently the moon is on when any planet is actually close to the sun, their light is actually extinguished for the duration within a certain degrees. And there's a lot more in there. I still don't understand about it, but it's all connected back to the whole Vedic model. Actually, that's what I can see about it.
Okay, series. Stan, your version for Mark Sargent.
Right. No, it's just same as Chris. Shadow. Everyone really. We're all, we've made the shadow on Z Proxy's model go the correct way, and everything's set at the right sizes and distances, and it's not working. I don't know if Mark, if you've got a VR headset, if you've ever tried VR headset.
I have not tried a VR. Well, I mean, I know of them, but I haven't tried them recently.
yeah, you should really try one. Like you would enjoy it. It's a real eye opener, you know. But you can, all the model and the videos are on C-Proxy's YouTube channel, so you can go on there and anyone can go on there, have a look. But yeah, it's just there's problems. It doesn't work. So that's my take. Everyone's the same. We've all been through it all, and you know, no one's been able to make it work correctly with working free balls, you know.
Yeah, like I said before, isn't it always amazing that when NASA goes to explain it to us dummies in the public, they always use these computer-aided drawings. They never give a real example. They never set up a real, experiment and take a photograph, and explain, see, this is how a larger object can make it. It's always a cartoon. Everything that you can see comes out of NASA is nothing but cartoons.
You think they would, as it's like the year 2017, though, wouldn't you?
You would think with a $20 billion budget, I could see something.
Well, that's it. They're meant to know it all, and yet they don't know. They can't explain this to us, you know. Whatever they're saying to us is like, go away, think about it, come back. No, it doesn't make sense, you know. Got problems. You still got problems here.
Thank you, Stan. And Turquoise Dragon.
Hi. Just it's getting people looking at the sun and moon a lot more, all this flat earth thing. If anything, the research community is making people even observant of the phases a bit more now. They're kind of like, just getting used to the stars. It's all angles and stuff, and how we're trying to work out how light works, and magnetism, it's all linked. That's the next thing, this whole battery earth, cell earth, or whatever you want to call it. It's a perpetual, it seems like it seems like does seem like a battery, like some saline, like electrolyte fluid, and it's got, you know what I mean? It's pretty amazing.
Well, have you watched any of Ken Wheeler's videos?
Oh yeah, I love Ken.
Yeah. Oh yeah, I love, and he shows you right there when he puts that magnet under that ferro cell, and you see the two dark spots. One's a north pole and one's a south pole, and you see that plane of inertia going right up the middle. I mean, it's the sky.
Oh yeah.
I'm a big fan of Ken.
Well, that's part of the big what they don't want you to know, right? Is that the entire system unto itself is a giant transformer of free energy forever. It's a perpetual transformer, battery dielectric.
That's where the power lies, isn't it?
That's where the power is. Yeah.
Yeah. Knowing of eclipses, right? In the ancient days, we're told that it was like, worship this guy. He could predict an eclipse is coming. It's just knowing this code and this cycle, you can have power, or whatever you want to call it, of foreseeing like current events, and I think that's the power they hold, basically, this clock and the plan around it. That's all the rituals and certain dates, and it's all set up to flow as it does.
Well, it's true, right? If you get into the knowledge and you learn the cycles, and that as the moon, this eclipse marks a point in time when the moon is now tracking north. Like each eclipse, if you look at the map, at every 100 years, it tracks something near 11 degrees north, right? So that tells you that it's the track is moving north. And when that happens, the dielectric causes cooling. So we're going into a cooling cycle, right? And they try to hide, I think, at least in my opinion, they try to hide a lot of the information, because if you actually know the circuits, well, then you can predict things such as crop markets, wheat futures, et cetera, et cetera, et cetera.
Mm-hmm.
Right, rise and fall, right, based on the weather, because it's the weather and the natural system that drives society and humanity and our reactions to nature, right?
Thanks, Chris. Can I just say, Patricia, your thoughts on the eclipse?
I don't really have any thoughts on it. I just think it's fascinating. I think this will be the first time that I've ever researched the moon, the sun and the moon. But yeah, I just think it's fascinating. I mean, I don't really see the moon much. That's probably because I don't go out much. But, it's always because it's quite built up around here. So I have started going out a bit more and trying to take photos and just to see whereabouts it is. So I'm just fascinated by all this. I love everything, but I don't have a take on the eclipse of anything because I'm quite thick, really. But anyway, that's it.
No, you're not.
I am.
But well, thank you for that, Patricia. But I do think she's right in the fact that this will be the first time that so many people will be interested in the eclipse. It's not just something they're going to be filming and then when we turn the television on, millions of people will be out hopefully watching this. Good thing. But anyway, we've gone through the list of people. Mark's talked. I don't know if it's just to open the floor up and to just talk to each other, about the eclipse. That's what we're here for.
I have a question. It's kind of just an open question for the panel, maybe to discuss. Is as we watch this eclipse event, and Mark as well in the U.S., And I just shared my screen there just as a visual reference here. This is just a model. I'm actually trying to do it on a flat plane model, and it works the same. If you rotate the sun, east to west, you can get the shadow to do the west to east based on the angle. But just for people to keep an eye out for is it might be easier to look for things that we would expect to see that we're not seeing versus what we're seeing, and then trying to explain what we're seeing. Like when I model it with an atmosphere and a dome type atmosphere based on the WGS 1984 ellipsoid shape. I mean, that's the scale as far as how we survey everything in a geodetic system, and then the sun and the moon. I notice that when it renders the shadows, you will see, just as the moon enters into the sun in the sun's rays, you will see a crescent form just for a few seconds, and then it goes black, and then it comes back out. But in reality, when the eclipse happens, we don't see any crescenting or any pre-crescenting of the moon until it goes to the diamond ring phase. But one would expect, just using common sense, that you should see something to indicate that is definitely a solid moon object entering into the sun's field, right? And then when I move it here to more to the center, actually go to real quick here. It takes a minute to render here, but I'm going to rotate on the Y, bring it up top so you can see that it's a functioning eclipse simulator. I can kind of roughly simulate the diamond ring effect too when you take it vertical. So that would represent totality, right? But we should see, like I said, something in that light path that would indicate some solid proof that I'm causing that eclipse. Just the panel's thoughts on that.
Hey, Chris, let me ask you a question. What's your thoughts on these stories and legends of these alleged shadow planets, Rahu and Ketu? Do you put any thought into that? Do you think that might have anything to do with this at all? Or what's your thoughts on Rahu and Ketu?
I definitely think that, those legends and stories are kind of derivative of this observation, right? No one's ever seen the moon come into the light and exit the light, right? So our eyes don't see the moon. Well, then they either projected it. Well, it must be something else, right? And then Rahu and Ketu are either mythologically created to explain what we're not seeing, right? Or perhaps there's ancient civilizations that at one point saw them and then carried through our civilization. But that's kind of where I think this is what we're seeing here, right? You should see some evidence of a solid object entering into the light and exiting, either in and out, but we don't observe it in reality.
Yeah, I wouldn't write that off, but how do you go about testing that? How do you go about finding them,
Well, this is it, right? There's also some scientific evidence that during an eclipse, a pendulum can be affected by the magnetic interference and the actual shift in magnetism. Like a swinging metallic pendulum at totality will change its direction as the eclipse goes over. It'll actually tend to follow the eclipse. There's physical measurement that can be done, right? So, to me, that says that it's definitely an electromagnetic effect. There's something electromagnetic happening during an eclipse that's measurable. Right?
One other thing that's noted as well, Mark, by the way, Patricia found out that on Eclipse Day, Big Ben, which is the Houses of Parliament in London, is being turned off for 4 years for repair on the Eclipse Day. I thought that was a bit strange because that's like stopping time, isn't it?
Which one of the houses?
Big Ben.
Oh, that's interesting.
We should also be watching the Foucault's pendulum and see if that thing stops, because they say during eclipses that Foucault's pendulum always acts funny too. So if anybody gets out there by that, lie, because that's what it is. But
just thought it was really strange that they were, turning Big Ben off.
That is really strange.
It's quite a long time, isn't it, as well? Did you hear that, Mark? They're turning Big Ben off.
I did. And I'm also, and I didn't even think about this. I just typed in closing on Eclipse Day into Google, and a lot of schools in the path of the blackout are going to be closing.
Really? That's odd.
Yeah. Well, maybe they...
Do you think it could be frightening for the children to suddenly see it's dark?
Well...
because that's a huge electromagnetic phenomena that's happening, maybe, and it might be messing with, the electronics in the school, certain buildings, possibly. And they're trying to hide the fact that this is an electric universe. They're not just trying to hide the fact that it's flat. They're also trying to hide the fact that it's electric also. And this eclipse is definitely...
Yeah. I'm basically looking, everything that's in the path of this, there's going to be closures all along that route for whatever. Maybe they're worried, I don't know, maybe they're worried about traffic. Maybe they're how parents are. Parents are worried about their kids. They, if getting to and from school, they'd probably just close it because of that, if there's going to be a traffic jam. So
excuse.
Yeah, so it already sounds like a strange day already, doesn't it?
Well, yeah.
Schools closing. Big Ben's going to be shut down.
Yeah, gravitational, like there's, well, they call it gravitational, but that alias effect is what I looked it up to make sure I wasn't talking things that weren't true for sure, but it's called the alias effect or alias effect, alias. And it's actual measurable gravitational changes and so forth. And pendulums are affected. It was discovered back in 1954.
I was just thinking, could we not set up some experiments on the day? Some pendulums and.
Yeah, I have some friends that are trying to do exactly that. Yeah, they're doing, the full telescope, the full pictures, the whole 9 yards with the pendulum. It'd be cool to have some gravitometers. Even check your cell phone. Like if you have a cell phone that has a little tiny, gold thing in it, put it on your compass. And when you're standing underneath turn on the cell phone as it goes over your head and see if anything happens to your phone compass. Right.
Here's a quick thing for you, if you guys don't mind. There's an article. This is in Portland, Oregon, and this is where I'm going to be. Right, I'm going to be in Salem for the event, and this was posted 4 days ago. Salem, Oregon, businesses are beginning to pull the plug in Salem for August 21st. They are telling employees to stay home and announcing they will stay closed for the day due to the eclipse and the chaos expected to come along with it.
Wow.
So, and you got to remember, so what? All restaurants are going to be closed? What, grocery stores? What are all those people going to be doing when they're there? You better, I mean, seriously, anyone that's listening to this, you better pack a lunch. In fact, I am definitely packing food for this.
Yeah, be ready to camp in your car. Absolutely. Yeah.
I mean, it's amazing. It's like, really? You're going to tell the whole city to Salem is where a majority of the Oregon's 40,000 state employees come to work each day. So like a lot of the government employees are going to be there, being told to work from home if they can, or to carpool if they have to come in. And even in Portland, which is,
this does sound like they're going to do something, doesn't it? It does.
Oh, don't tease me. It'd be so great if it did. I'm sorry. I've been a prepper for a long time. So
just wait.
Pull a pin already. Get it over with. Yeah, pull a pin. Come on.
I got to tell you, I will be severely out of position. Well, not severely. I'll still would be within 3 hours of where I am now, but it'll be a tough slog back if I have to deal with a whole bunch of whatever happens. That I'm pretty sure that the eclipse is going to turn a whole bunch of people actually into zombies. So when that happens, it'll make it much more exciting. Messing with you, that's not going to happen.
But everybody's going to be looking up.
Yeah.
Must be that. It must be that everybody's going to just stop and then look up. But this is going to take a few minutes, isn't it? It's not like it's going to happen in 1 minute.
No, it'll take a few minutes. And of course, it starts building. It starts getting dark quite a bit beforehand. I'm trying to read the thing of why exactly their excuse for doing the school. It's a safety concern, but it doesn't say exactly what the reasoning. Oh, I get you. The schools are citing safety concerns since the eclipse will happen during dismissal and buses will be on the roads. Yeah, that's what it is. So if you have, it's a traffic thing because traffic is anybody in the path of this. But remember, sorry, and I don't want to dominate this thing by any stretch. The big thing here is that even if you're not in the path of total blackout, the entire United States will be able to see this. Everybody from New York in the Northeast to Los Angeles in the Southwest will see this thing to some degree. If you're in the United States, you will not be able to avoid it. Even in Los Angeles and New York, you're still in like the 75 percentile, and like where I am right now, I'm in the 93 percentile. So I would see most of it anyway, and we're only driving a few hours to get total blackout because that's what you do, right? You want to be at ground zero. You want to be in the middle of the chaos.
You are.
Everybody just starts freaking out and running around with pitchforks and torches. That's where you want to be.
I'm in Canada, basically on the border of Maine, and we'll have a pretty good shot of it here too. Like it's not going to be totality, but it'll be visible.
It's about 90% where I'm at in Canada, Ohio.
Yeah, and there's a lot of big cities in the 90 percentile thing all the way across, so it's gonna be interesting. Anyway, sorry, go ahead.
No, I'm gonna be down on the coast.
We're in here to chat together.
Yes, but that implies that I like you, and I because you're from England, and Americans hold a deep-seated resentment against anybody who's over there.
Oh, why is that?
Much like my eternal hate for the Eskimos and the Sherpas of the Himalayas.
Don't forget the gray coat. The red coats of Canada. Absolutely. Yeah.
The red coats of Canada.
United Empire Loyalists. Yeah.
Nice.
Yeah.
Nice. I'm sorry. Every time I think of Canada, I just think of the Royal Mounted Canadian Police. The red uniforms and those big boots. It's hilarious. Those heavily pleated pants.
Rocky the Squirrel and Bullwinkle.
Exactly. I'm sorry.
That's just wrong. I'm sorry, Canada. We love you guys.
I know. I know. I mean, I got a chance to spend, a year up there, and it's really not that much different other than your taste in food. That's really it. The rest of it's pretty much what we have. You have pickle flavored and ketchup flavored potato chips and pierogies. I had to figure out what those damn things are.
Words like a boot. So
Yeah.
I wouldn't know it was a Canadian until they say a boot.
And not everywhere. So
what are you talking about, eh?
Say it. Come on,
Sounds like
Chris.
somebody's been watching South Park.
Exactly. Yeah. Exactly. But,
Chris, say about. Go on, because we say about.
About.
You say it then, Chris.
What are you talking about? A boot is more like a boot. Yeah, an A. You say A pretty much after everything.
Yeah, I'm unfortunate enough to live in a part of the country where there's no. It's an accent, but it's kind of a lack of accent. Everyone over here talks like they're newscasters. All the newscasters talk the same, and we talk like them. We don't have a Southern drawl or New York or Boston or Texas or Minnesota or any of those places. We're just kind of talk like people on TV. Anyway.
I definitely think it's fascinating, like Thomas was saying, that the effort that mainstream is going to, against the flat earth movement. I saw a couple of articles today that were in the Metro and the Mail featuring Cindy Holland, I think her last name is. I can look it up here too, and they're basically attacking flat earth mothers in these two
Yeah, I've
papers.
been seeing that. I've been seeing that article the last 2 days.
Flat Earth mothers being sucked into Flat Earth, I think the title was.
Yeah, and she's a former NASA employee from the United States, right? And
She is. She contacted me a while ago, and she was good, but she was more of an admin. But she was on a first name basis with a lot of people that were, in that program. So she got the pictures that she showed me. Her standing on all sorts of things that weren't exactly classified, but it was pretty neat. And again, the one story about her when she was hanging out with some guys, and they were kind of joking. They weren't talking to her, but they were joking to each other, like how people believe everything, all the space stuff, and they were like making fun of the people that believed it. It's like, can you believe, that they're just buying it? And yeah, I would probably laugh the same way because their production value is not good. It's I never thought it had any quality to it, but now it's especially bad. Even oh, there she is. Yep. Even now it is not aged well. It's never aged well from any of the stuff. I mean, I show people even just a couple clear Apollo shots taken from the moon. It's like, look, there's too many things wrong. And but again, the people, why wouldn't they buy it? Because science would never lie to you. That's the thing. It's amazing what putting a white hat on somebody will do for you as far as credibility goes. NASA, they wear white uniforms, they smile for the camera, they don't carry guns, and they do, they're the front men of science, and people are like, these guys are totally legit. They never steer us wrong. Well, to steal the line from
Truth.
the what?
They've never told us the truth.
Right.
I think it's the
Well, they
money
taught us
as well,
what they believed. They taught us exactly what they believed, and what they didn't teach us was critical thinking abilities. They didn't teach us how to critically think. They didn't teach us how to investigate subjects. They just taught us to remember and repeat.
Yeah, exactly.
You do it well enough, you get a degree. But yeah, at any time during this remember repeat process, you have a wrong fact in there, then that wrong fact is going to get repeated and repeated and repeated. You're going to be like, well, my teacher would never lie to me. I mean, she taught with conviction, I could tell in her voice she believed what she taught. So I didn't think for a minute my teacher never lied. My teacher taught me exactly what he or she believed 100%. And when I even had teachers that when things didn't line up in the books, they would go out of their way and get other scientific articles and bring them in. And they would show us what was in the book and read what was in the book because they had to according to the school plans. But then they would show us this other article saying, well, this is how this proves this or disproves it or whatnot. But nowadays, you aren't allowed to critically analyze anything. If they tell you evolved from a monkey, then that's what it is. If they tell you a space blew up from nothing one day, then that's what it is. If they tell you water can stick to a ball, then that's what it is. We no longer have the ability to question what those in authority tell us. We automatically assume Donald Trump could come out there and say the sky is purple. Half the country would believe it. They making doctor's appointments, talk about something wrong with my eyes because I'm sure the sky is purple. Donald Trump said it. But,
yeah, it's the subtle fine print in these types of articles that really gets me going. It's like in the fine print, right? It's just, we're all being conned. Picture supplied. Well, supplied by who, right? It wasn't supplied by her, the Metro. Right?
Yeah, this is really a psychological war more than anything else. Yeah. This is a psychological war.
It is. It's a psychological psyop. More than just psyop. It's psychological warfare.
Yeah, that's exactly what it is. Proving the Earth is flat is not difficult. It's not high science. You don't need to go to college to be able to figure this stuff out. But the way they got us taught, we're never going to figure out. We're never going to want to question. There's too many other things we have to do. We have to worry about our job. We have to worry about our life. We have to worry about partying and having fun. All that.
Thomas, could you just come forward a bit? Oh, because you've moved away from the microphone.
Okay. Yeah, I was just saying we don't in our society today. We have our society built where we really don't have time to critically analyze everything around us. Basically, if I ask my neighbors, "Hey, did you know the Earth is flat?" and they'll be like, "No," and I don't care. I got to be to work here. I got bills to pay. Is that going to pay my rent? No. And they don't see the bigger picture of it all, so they're not even bothering because they're so caught up in the system. So yeah, again, it's a psychological war. It's trying to wake up the prisoners when they don't know that they're prisoners.
Yes, that's it. Most people don't know they're prisoners. Could I just say that Mike Helmick's joined us now on the Hangout. Hello, Mike.
Mike's doing mic issues. Hello, Karen. Mark Sargent, glad to finally meet you, sir. Thank you.
Nice to meet you, man.
Yeah, enjoy your stuff. Thank you for sharing my videos too. And I'm done.
Well, what it was is we were doing we've just been doing our version of the Eclipse. So what Eclipse then?
Well, I've been talking to Chris Monk, David Marsh earlier today. The Eclipse, the way the moon actually works on Earth, the Eclipse may be a little more complicated than what we thought. And so that's what we were discussing earlier today. And I'll let David or somebody tell you what we were talking about while I get set up here.
You mean you're talking about the way that with the little video I was talking about where it flips and we can't see it flip? You're talking about that bit.
Right. The moon flips only on the northern and on the equator, north and south. The moon does not ever flip east and west. So if it's a perspective thing, the moon would also have the same effect. Like David Marsh has some pictures from Alaska to the UK. I got one of his pictures from Florida, same time sync to the UK that he had taken. Somebody else ran a video on. I got David Marsh's photos of the moon in these other places. The moon never changes orientation. The only perspective the moon changes is when you're looking at it passing east to west. It'll get an orientation change due to that, but it doesn't spin or rotate. But when I was looking at Wolfie's photo of his eclipse in Australia, and I can show you demo of this. I'd have to share screens, but the moon is here in the Indian Ocean, and in Russia, the moon is upright like we always see it, and all the features of the moon are always in the same place. And if you move your camera, it'll spin, but it's not quite the 180. It's not even close to 180 degree flip that Wolfie showed us, and that was my message to Wolfie. How do you get the moon flipped upside down a perfect 180 degrees if the moon's over the Indian Ocean? And he doesn't know. And Wolfie's a globe earther, and most of you already know who he is, but he couldn't answer my question. He doesn't know, and you can't flip the moon. So if you go south of the equator, the moon always orientates the same way, same pattern, moving east to west. They see the same thing we do as the moon moving east to west in the northern hemisphere. And so when I was trying to model this, I ran into this and realized something very strange is going on here. It's the same with the stars, the Big Dipper. David Marsh and I can see the Big Dipper. He lives in the UK, I live in the US, and it appears orientated the same way up to both of us. You cross the equator line, the Dipper flips upside down and inverts. And those stars are supposed to be millions of light years away, and so it makes no sense. Yet, if I were to take a picture in North America of the Big Dipper, and David was to take a picture of the Big Dipper in the UK, the Big Dipper doesn't revert that way. It only reverts on the southern northern hemisphere at the equator. That's the only time it flips. And if it was due to perspective, Karen, then anytime you pan the camera around, it should be relevant all the way, and it's not. We only get the flip at the equator. in on that.
Well,
It sounds like what.
I'll just sum up a little bit on that. On the equator, I mean, I'm only going by what I've actually heard from other people, like my friend Anderson in Brazil. And what actually happens there is when the moon, it basically goes straight overhead. So as that moon's going overhead to them in one perspective, for the 180 degrees flip, they have to turn around like that, and they see it facing the other way. That's how they get the 180 degree flip in Brazil, because it's going that way, and to see it again, they have to turn around 180 degrees, and it's upside down. That's how they get the flip there. I know that for sure, because my friend Anderson's documented that quite well, and I've seen the actual image flipped completely 180 degrees the other way. So that's my thoughts on the equator. But like Mike said, from Wolfie's perspective, is in Australia, Mike Wolfie?
Yeah. Wolfie's in Australia.
So there, I'm not 100% sure, but like I say, I'm confident. I know how you get that 180 degrees turn on the equator, but from Australia, I wouldn't know unless I actually went there and actually observed myself. A lot of these observations are quite difficult to try and picture in your head unless you've actually been there. You know what I mean? Like I say, I presume my friend Anderson thinks it's weird how we see the sun and moon go around us, because he literally just sees it go one straight over his head every day. So it'd be interesting for me to take a trip one day to somewhere near the equator just to actually see it, because like I say, I've heard from a few friends that he says it just literally goes way over your head like that.
Yeah, it does.
That's my thoughts on that.
Yeah, we've synced it, all three of us. Like, we've got UK, we've got Estonia, and we've got Cape Town. You know, you can see there is a rotation to the moon as it's passing around you, but it's like you have to watch all of the videos. We haven't actually been through it all yet and made a model of it, how it's doing it, because what we're seeing is some crazy stuff, you know. Like, you can't have one object, so to speak, doing what it's doing. You know,
Stan,
with the free. Pardon?
Sorry, I was going to say, you know, Cosmic Surfer. Does he see the same perspective where the moon like goes over his head and he has to like turn? He can get 180 degrees different angle on the moon.
No, his is down a little bit. It's not right over his head. You know, he's looking up a lot higher than we are, but it's not right above his head.
He's quite far off the tropics, then, is he?
He's a bit off, yeah.
Cape Town.
Cape Town.
Yeah,
with the 360 data, so you can back it all up. Like, you can go out, film with your P900 and then have your 360 running, so then you know where the moon was in the sky when you're filming with your P900.
Hey Stan, we've got Mark here. Mark likes his gadgets and things. Tell him a little bit about the 360 degree camera.
That's the only way to watch the sky. You haven't watched the sky until you...
Tell him what you see. Tell him what you see with the camera.
Rainbows. The sky's a rainbow. You can't triangulate anything up there, you know?
Rainbows during the day, or?
No, like, the moon acts like a rainbow. The sun acts like a rainbow. The stars are acting like, you know, everything's a rainbow.
Oh, so it moves with you.
Yeah. I think, like I was just about to say.
You can't triangulate
a rainbow.
Yeah, that's what I say to people. Can you triangulate a rainbow? No, you can't. Can you get to the end of a rainbow? No, you can't. So you're never going to get to the moon. You're never going to get to the sun. You know, they just move with you.
That's fascinating. Yeah. It doesn't surprise me.
No, you need to get a VR headset on and then look at my moon pictures, because you haven't seen the moon until you've seen it in a VR.
Hey,
I have like I'm up to 7 months now of 360 data from my roof, just watching the sky every day, and then we put it into a composite, so to speak, with all of the paths of the moon, and yeah, you just have to see it to believe it.
Are you suggesting that what we're seeing is a reflection, or is the moon a solid object? Is the sun and the moon solid objects, so they are light reflections, or constant light concentrations?
I think of it as a projection kind of it from our perspective, and our atmosphere is actually like the perfect lens kind of thing. That's how I see it. And I've put some interesting videos out there. One from my friend Jose in Portugal, who put one of these little adapters on his iPhone, you know, gives you a little bit of a zoom on it. And when he captured the moon, the moon was overexposed, and it actually produced a perfect image of the moon, but inverted. And it was absolutely perfect. So it just looked like basically the sun, and the actual reflection, what was reflected on his actual screen, was a perfect projected image of the moon, which was quite interesting. And I try and imagine imagine it something like that on a massive scale kind of thing. So the light's been projected from the ether, and from our perspective, we're seeing a larger magnified projected image, where it just looks so perfect because the atmosphere is the perfect lens kind of thing.
Yeah, I've got some for Mark here concerning along this line. Now, what you're saying, David, I didn't see that, passing over at the equator. If we're right center equator, we're looking at the moon. I don't know what we're going to see. But anywhere else, like if I'm in Florida, you're in the UK, we should see the moon flip, much like we do on the north and south. We should see the same effect because it's all perspective. We don't. We never do. At the equator, what you're talking about, David, is we see a mirror, right? Is that what you were talking about? We see things kind of mirrored over on the equator, the stars, the moon. It's kind of weird that way.
Yeah, I thought about that, and actually, Aaron Dover did quite a good video on this quite a while back. Bless him. I know he's passed away now, but he did a really good video on about how every star is basically reflected, and he actually identified certain stars and obviously matched them up from the north and the south, and he was absolutely perfect, but just completely mirrored. So I haven't actually looked a lot into that, but like I say, in regards to the moon, from my perspective, I'm going to say it's a projection, and I'm going to stick to my guns because that's what I believe it is. And
okay, I believe it also is. I also do believe that from my evidence, it looks like it's projection and reverse reflection at the equator. And now, since I have Mark Sargent on, and since we all loved his flat Earth clues way back, and that's what I started listening to. Is I started listening to Mark. Mark talked a lot about Operation Fishbowl. Of course, we know they were on the southern corrugated region, and right along the same latitude line, way up above across the equator, they were doing test and research on Johnston Island, right? And we thought maybe they were trying to go through a dome or something. But when you read the research in it, and it's right along the lines of what we're talking about, okay? It says the aurora is associated with high altitude nuclear explosions, especially the auroras that appeared instantaneously far away from the explosion in the opposite hemisphere were not clearly understood. In other words, they would blow something up over in Johnston Island, and they would see the reflection and have it appear all the way across the equator into the southern hemisphere through magnetics, because they were checking the auroras through magnetics. They would see it instantly appear on the other side in the southern corrugated region just east of Fiji. And now, after studying the moon, I understand more of what they were probably trying to do here in Operation Fishbowl, because they were testing auroras and magnetics at these two locations. And so I found that very interesting once you get an understanding of what the moon is doing and how the stars flip only at the equator, and they don't flip east and west like they should. And so they're testing magnetics, and these auroras are automatically appearing in the other hemisphere based on the magnetic lines running up and down across the equator there.
Mike, didn't they actually have a blackout in somewhere in Australia as well? I read due to like an EMP. I'm sure I read it somewhere that they had like a blackout somewhere.
I didn't read that in the article. I'm not saying it's not possible, but possibly. But they were testing aurora patterns through the magnetic field. That's what they were testing Operation Fishbowl, and they are seeing this teleportation and instant flipping back and forth from two places that are very far apart on the same latitude line. And we know what we believe Earth is. That latitude line also possibly represents where Earth repeats. So I just found it very interesting reading what exactly they were doing for that. And
interestingly, Mike, the sun mimics the full moon's location nearly perfect on the opposite latitude. So when you have a full moon in summer, is high on the Tropic of Cancer in the UK, the moon is always furthest away on the Tropic of Cancer. And as the sun moves closer, the moon still has to do its 27.3 day cycle, so it still has to reach its limit at the Capricorn, then move forward, but it mimics that moving forward of the actual sun. So it'll be slightly closer then. Then on the following full moon, it'll still make that journey, then it'll come back and it'll mimic the same distance again on the opposite hemisphere. Then there's a very close point on the equator, on the equinox, and then there's a switch, yeah? Then the cycle reverses. And then what you find is then in winter, the sun's low on the horizon, and the moon, always in the opposite hemisphere, is way high in the sky there. So that's quite interesting. And I've checked this, and I'm sure I mentioned it before, I've checked back through about 120 years, and you can't have a full moon moon and the sun in the same hemisphere. It's impossible. It matches it perfect, no matter where it is on either side of the actual equator. So that's quite interesting as well.
Right.
And a lot of the stuff that you give anyway, because you gave series 100 years of moonrises. No, it's just incredible. I think that really gets me. 100 years.
Yeah, like I said, once you know the math, you can predict 1,000 years. You know what I mean? It doesn't matter. There's only a certain amount of years. I can't remember the actual how many years the lunar cycle is. I don't know if it's 19 years or something like that. But once you've got to that cycle, then it'll just repeat itself. So it'll just continue. That's why they're able to predict eclipses, and there was hundreds and hundreds of years ago as well.
So I want to say something, but Mark, what do you feel when Mike said that's what Operation Fishbowl was about?
Oh, I think that's fascinating. I've never heard it, and that makes sense. It does, because I was wondering. I think they were trying to do things on multiple levels, but yeah, firing those weapons up there, because and Mike can comment on this. What was interesting for me wasn't just they were firing stuff straight up; it was the yield that they were going for. So those first 3 shots were all in the megaton range, and everything after that for the next 3.5 years were all in the mid kiloton range. You know, I mean, still bigger than Hiroshima and Nagasaki, but not really that big. It was like I was kind of trying to figure out. It was like they were trying to paint the sky, like try to figure out. They were using it as a like a marker, like using paintballs to try to determine the shape of something. And that was initially my impression. But what you're talking about here is more advanced. I like it. I like that they were toying with the magnetics.
Yeah, and first of all, thank you, Mark, for bringing that to everybody's attention. I'm sorry, Karen, I didn't mean to walk on you.
No, I was just saying.
Karen.
I'm saying that. Carry on. Just carry on.
Go on, Mike.
First of all, I wanted to thank you because when I first started looking at Flat Earth, I ran into you in Eric's material, and when you were talking about this, the Operation Fishbowl thing, it was just like, wow, fascinating. But your later assumptions now correct. Those larger yields at the beginning, they were testing the magnetic field, or trying to open something or cause a magnetic distortion that was permanent, where they could mark it to where they could test back and forth between the latitude lines. So they were trying to paint something. And then once you open that up, I guess, or once you have the magnetics to that going there, once you have whatever wave particles, if there's particles going, then you can send up lower yields, and you can see what's going on the opposite side of the magnetic lines across both hemispheres. And so I agree with you.
And you also got to wonder, again, no coincidence that the Russians were doing it simultaneously and, quit on the exact same day. You wonder where the Russian secondary point was. So the Russians were, doing all their tests on this one side, but they were probably also, they were kind of making an X. The Russians had probably another team in a different part of the world also trying to figure out what was going on. And it was between the two teams, they probably did a heck of a job, but it still took them 4 years to figure out whatever they were trying exactly to figure out. But yeah, in the end, again, no coincidence, they quit on exactly the same day. Oh yeah, moratorium. Really? Both sides agreed to the moratorium? Yeah, we're not firing up in the air anymore. It's brilliant.
It's just because they don't want to tell us what they're doing all the time. So they just make something else up. Tell us one thing when it's actually something else.
Yeah. Well, the Cold War was a good excuse for it. And again, interesting that's all they were doing was aerial bursts for that much of a stretch. And they were not shy about it. They were firing those suckers up quick. And you got to remember, this was no cheap operation. I mean, this was back when kiloton and megatons were extremely hard to come by, very, very expensive. And they were committing everything they had to it. So fascinating though, the whole package. Yeah, of course. Some people were saying, well, Operation Fishbowl was too obvious an operation name. I'm going, well, it is now, but back then it wasn't an obvious operation name. Back then it's like nobody knew anything. It was just Operation Fishbowl was just part of a bigger series of packages. And the Russians didn't even bother naming their stuff, just Russian numbers.
It sort of makes sense when we're flat though. Yeah. Because they knew all this. So for a ball or anything like that, they're doing it because they know what we're living in. Yeah. And what my point about the moon rises is that all that information comes from the military. One day, me and Ceres were trying to find the moon rises and the moon sets. Instead of looking on the moon, whatever it is, the day and time thing, we tried to go somewhere else. Basically, I found somewhere else and I went to give them the link and it said military. So it was the military giving you this information. information.
Sure.
So it's like they know what's going on.
And don't forget, again, let me throw in this little shot here. A lot of people forget NASA isn't just most people don't even know that NASA is part of the Department of Defense, right? It is absolutely military, but it's uniquely military. The whole, I mean, more than the Army, Navy, Air Force, Marines, and all the other smaller factions, not to, give enough credit to the Coast Guard. They do their best. But NASA is so uniquely military because the whole thing is based off of the still burning embers of the Nazi war machine. The missile technology. It's basically a missile program that has a few people involved. That's basically it. It's a missile factory with a few people tied. It's apparently riding some of these missiles places. It's very, very like Antarctica, very unique among the military services. So my little jab at NASA.
Oh no, thank you. Well, yeah.
Sorry. I'm sorry, kid. What Mark said when if you listen to his Flat Earth clues, he ties in Operation Deep Freeze and what Admiral Byrd was doing. All of a sudden, bam! Now we have Operation Fishbowl. We have the formation of NASA. So whatever they found North and South Pole, whatever we're finding with the moon, because folks, the stars only flip on the equator. Okay, they don't flip east and west. If it was due to perspective, it would be east and west also. It's not. There's something with the equator. It's something they're mirroring. It's something we're testing Operation Fishbowl. And this all came together back, and I think Mark's Flat Earth Clues best tells the story, came together starting with the Admiral Byrd missions when they realized, we have a problem with Earth. And that's when we started seeing all this action and parties formed, especially what Mark said, the Nazi war machine. So that's my 2 cents on that. It's all making sense now from what everything Mark said way back and the things he described and figured out, and to what we are finding out today. Hey, it's crazier than we thought. That it's all coming together, and now we have to figure out how does it work.
Interestingly, Admiral Byrd's first mission, that was actually funded by the Fords and the Rockefellers. You know what I mean? And they're obviously gentlemen of power. So clearly they wanted him going down there for another reason other than to find snow. They was definitely looking for something else. What they were looking for or what they were trying to do is anyone's guess. But you know what I mean? For people of that stature to get involved, then they must be looking for something serious down there.
And they still haven't. It's been an ongoing thing, and it hasn't stopped. It's still continuous to this day. I know I shared some information with Mike too on barium, and NASA's been launching barium particulate, by the ton for 30 years into the upper atmosphere, ionosphere, using barium. And barium is a microwave. It's a non-natural microwave type of a particulate. So you can actually spray that stuff up there, and then you can see the magnetic fields with the radio telescope and study the fields. Right. So they haven't stopped. They just changed it from nuclear to barium, right? And different sulfates, and that hasn't stopped. Yeah.
So are you saying, Chris, what I suspect, they're still clueless to this day?
I was going to say, I reckon we are closer than what they are, really do. I don't think anyone's as close as what us lot are,
We're right on the cutting edge. I mean, the stuff that we're doing, and when we start looking into the barium, the white papers, and what's going on with why they're trying to study it, and, I find it interesting. NASA's been spraying this barium stuff, and like I said, in the air for decades, and then there's a young astronomer girl that gets nominated for a prize in scientific research stuff because she discovers the magnetic tubes. Well, I hate to burst your bubble, little girl, but those tubes were probably created by the barium that was been sprayed in the atmosphere, and the only reason you can see them now is because there's enough radiation and particulate up there to make them visible, to your equipment. Right?
I don't know about anybody else, but it seems the more and more you put into research Flat Earth, the deeper the rabbit hole goes. You seem to get like three sides of the puzzle in place, then the fourth one never fits. It's like
the matrix. Then it's a matrix.
Well, like I say, when I did my moon race video and I recorded the speed of the moon, and it speeded up when it left the Tropic of Cancer to the equator, and then it slowed down when it went to the Tropic of Capricorn, and then it stayed at the same speed all the way back, which made no sense at all on any model, whether it's the global what, you know what I mean? That doesn't fit in any model, really. For it to speed up significantly to the equator, then to slow down, and then to stay at the relative speed all the way back and repeat that cycle. And it repeats that cycle. You can go for years and years. I've been from multiple locations, measuring that culmination of the moon, that gap in between meridian passings on consecutive days, and it's same. Doesn't matter what location you're at, you get the same speed up and the same slowdown, but it doesn't fit any model because, like I say, on the circle model, you need it to speed up. Obviously, when it went further south to the Polar Tropical Capricorn. On the globe model, it should speed up when it's approaching perigee. Obviously, it's the closest approach to the Earth, but it's doing opposite that. It's speeding up as it's leaving towards apogee, if you know what I mean. And on the square model, you'd expect it to stay at the relative same speed, and it's not. So it's just one of these puzzles where it just doesn't fit any piece. You know what I mean? No matter how much you try, I know we'll get there in the end, but it's just mind-boggling. It really is mind-boggling.
Well, this equatorial magnetic flip, like I would actually call it the electromagnetic equatorial flip of the light refraction and the light coming from above. It does not just apply just to the moon. It also applies to the sun. Mike and I were looking at that. The sunspots do exactly the same thing. If you compare Anderson-Neve's pictures in South America down in Sao Paulo to another friend of mine, Bradley Gillen's pictures, and he's in Montana, within a week span, they took the same pictures of the same sun, and you can see that the sunspots do exactly what the moon is doing. The sunspots, right?
They do that with the planets as well, Chris.
Right.
They do it. Everything in that belt, it will, when you go past the equator, it flip everything.
Yeah, so it's just not the suns, like you said, the stars are supposed to be at infinite parallax, right? So they shouldn't flip at all. The sun is supposed to be 93 million miles away, so it shouldn't flip. If the moon was closer, you could say, well, maybe the moon does it because it's a little closer. But no, it doesn't work that way, right? It defies the laws of physics, right?
Exactly.
Right.
Yeah, I took a sunshot today at 6 o'clock, and I posted it. And Karen B, she took one at that same time as well, and we compared them. And the sunspot on mine was at 10 o'clock, and hers was at about 7 o'clock. You know what I mean? So that few distance in 1,000 miles distance, looking at a sun that's 93 million miles away, we're seeing a completely different perspective of it. So how is that possible? You know what I mean? It wouldn't be possible.
What you need to do as well, Dave, is take one early, take one in the afternoon, and then take one in the evening, and see. I'll bet it's twisting like a clock.
Yeah, it does. It definitely
over 6 hours.
Like a clock. Yeah, it does. I haven't actually built my housing for my filter yet, so I'm just flapping a piece of sheet in front of it, and it's quite difficult. So when I build the housing properly, I will start documenting it a bit more.
Yeah, I think there's something we all need to look at, definitely.
Here's sharing a couple pictures.
Make it clear, just to make it clear, Chris, and what you guys are saying, just for the people listening to us, the sun acts like a real-time clock. Is that what you're saying?
It absolutely is, yeah. It's
okay. I just wanted everybody to hear that. Okay,
if there's a sunspot on the sun and you track it over time, it acts like a precision clock. You could actually time that one day and say, okay, this is how long it went one day. Start the next day, and you could track it to the millisecond. Right.
Mark,
like an
do you
atomic
see
clock.
the black spot on the sun on the left at sort of 10 o'clock, 11 o'clock? That's what Chris is talking about there. That moves around.
I've seen that on a couple of videos, and it's fascinating. Yeah, he may be onto something. He's not sharing his screen right now.
Screen.
Are you? Because I don't see it.
Yeah, I'll go back a couple of pictures here. So these are pictures by Anderson Neves. He's in Sao Paulo, Brazil, and you can see he's got some time dated on the bottom. So at 9:24 in the morning, he took a shot, and the sunspot is around roughly 11 o'clock on the clock. And then he took a whole series, but I just picked three of them to show you how it's actually.
Oh yeah, it is moving like a clock.
So by noon hour, it's at 9 o'clock, and by 14:22 hours, it's down around 8 o'clock on the clock. And he kept going, but over 6 hours, it almost went 180 degrees. Right, so 12 hours.
That's a huge distance, given that they say the sun is 400,000 miles across, or is that kilometers?
Well, yeah, exactly right. So it would have traveled some 400,000 miles, being 93 million miles away within less than 6 hours. Right.
You couldn't even say it's the rotation of the ball Earth, could you? Because it would have to it'd be like a roller coaster ride, wouldn't it? Can you imagine one of them you strap yourself into and it's going round and round.
And if you think about it, this rotation of the spot from north to south, and it reverses when you go across the equator. The guys in the North see it go the other way on the other side of the clock from north to south, but now it's going through 1, 2, 3, 4 o'clock instead of going 11, 10, 9, 8. Right? It reverses at the equator, and this completely busts the solar system model, because if you think about it, we're supposed to be on the equatorial plane of the entire solar system, and the sun's supposed to be going around in a circle like we are, and we're supposed to be going around it. So the spot should technically be traveling traveling east to west on the equatorial line of the sun, right? Going around it, not up and down.
It actually does on NASA's. If you look at NASA's time-lapse video, what they showed, it actually does go from left to right. Actually, you know what I mean? Because I said that. I says NASA is showing one thing, but in reality, everyone else is showing it's going round in like a clock.
sees something else. Exactly. Right.
They're saying the sun is 864,575 miles in diameter. So
is that diameter or circumference?
No, it says diameter.
Really?
Yeah, that's what it says here. I said, how wide is the sun? It says sun diameter, 864,500. That's what it's saying here, yeah.
Oh, all right.
That would make that spot 10 times bigger than Earth.
It says the radius is 432,288 miles.
Yeah, that's what I want. Oh, the radius.
Yeah, that's the radius, yeah, the radius.
Okay.
Surface temperature, 5,778. Hey, that's interesting. It says right here, the surface temperature of the sun is 5,778. And I'm thinking, isn't that what year it is according to the Hebrew calendar? Isn't this the year 5,778? That's just a weird little curious thing I thought I'd throw out there, but I doubt that's relevant, but okay, I just came across that.
Plus something else to throw into the mix. Chris, you were showing the stars, and you've got a take on the stars as well, haven't you?
Yeah, so we've been trying to develop our own little balloon program to get up there and take some better images, right? So rather than calling Wall Ops Island Flight Facility from NASA here, Wall Ops, get it? Wall, ice, wall, op. Yeah, that's a whole nother in-your-face thing. But yeah, the stars. Mike and I have looked at this, and I looked at it with some professional photographers, and we discussed
that picture there looks like the goddess Nut right there. Somebody showed me that today. I can't remember their name, but that picture of the Milky Way band right there, doesn't that look like the old Egyptian picture of the goddess Nut? She was the goddess that stood over. She literally was the firmament. She gave
over the firmament.
Yeah, she gives birth to the sun every morning, swallows it with her mouth every evening, and then gives birth to it again to start the following day.
Yeah, it does. Yeah.
It looks just like that Egyptian. I'm just waiting for her shoe to stand up in the middle and hold it up.
Well, the interesting part that I've been trying to study with these photographs, these types of professional photographs, some are time lapse, some are just high quality HD single shot photographs. I've compared hundreds of them. So anywhere where there's a salt lake or like a real Stillwater lake shot of a night sky over the water, you will notice that the images in the water do not match the sky. There's fewer stars in the water than there are in the sky, and in many cases you'll see that this one here doesn't exactly have it, but Orion has the three in the air, but not in it has them in the water. But you'll also notice, if you look close, you'll notice that, say, Orion's his sword will have 5 or 6 stars in the air and only 2 in the water. If you start matching them up, just start matching them up to where they appear in the water versus the sky, and you'll see that many of the stars in the sky appear to be self-reflecting. So you're getting multiple images of the same star going through multiple layers of a refractive type of infinity mirror. But only the ones that appear in the water, the light is coming in this direction. The rest is just reflecting outward, and you're looking through the fishbowl, right? Essentially, right through the fishbowl. Right.
Yeah, just on the back of that, Chris, and what I thought about is, remember we were talking about this on a previous show, that what I thought about doing when I get the right conditions to do it is actually I've got a mirror, actually, we haven't put up yet, it's quite a big mirror. I was going to lay it on the garden, and I was going to face the camera at it, and I was going to do a star trail off the actual mirror and see what I pick up. And so that would be interesting to see if it actually pick all the actual stars up, what's in the sky. You know what I mean? Maybe we could actually match it up with Solarium and see if we have like a match, which would be quite interesting.
Yeah, it'd be good to see if you can do it into a mirror. Exactly. Yeah, do some experimentation. Take a picture of the sky, turn it around, take a picture of the mirror, compare the two images, see what doesn't appear in the mirror versus what's in the sky. Yeah.
Yeah, so this is an ask for anybody, because obviously loads of people are talking to Chris right now. He would love any pictures of anybody taking pictures of the stars in water. Are the stars matching up in the water as in the sky?
And in a mirror, right? Take a big.
Love those pictures.
And I have something to add to that, if I may, Karen. if you send pictures to me, Chris or David or Mark or anybody, if you send pictures, please, if they're raw, please do not send them through Skype. Zip them right away. Because if you send them like through Skype or you just email the picture, they go through a compression through the Google server, and Skype has their own anti-noise compression they go through, and it will destroy anything amazing that we might be able to take out of those pictures. So if you take any raw pictures, zip them, please send them that way.
And you know that already because you've had some information and they did it that way and you couldn't see it properly.
Yeah, we're doing NASA raw images. NASA has no raw images, by the way, but we would get different information when we send them through just email plain or send them through Skype. And what we realized is the Google servers, when they check for viruses, and same with Skype, they recompress your image for you, and that's why. And then we couldn't get the same information forensically through photo forensics, and we couldn't figure it out. Now we got it figured out that if you email it or send it through Skype and you don't zip that raw image first, you're going to lose and change valuable data, especially light data, photo, which is very important. You're gonna lose the quality of that.
Thanks for that, Mike.
I'll keep that in mind because it's same with Facebook as well. When you upload images to Facebook, I've noticed the actual big dip in quality. You know what I mean? You can see a hell of a big dip because I was looking at the sunspot today on my image on my laptop, and then when I sent it to Karen and I clicked on it and zoomed in again, quality had gone completely. It really took it down, so it does make a hell of a lot of difference.
Yep, add that to Facebook too. It's true of all the social medias and your email. Make sure the file's zipped, so otherwise it might not be useful.
I was just going to say, Hotmail, we managed to send 8K images to each other through, not Hotmail, Hangouts on the Hangout Messenger. You can actually send good quality photos to and from each other on that.
Thank you, Stan. Thanks for saying that. So there you go. Then maybe that's another way. I just wondered, Mark, what do you think when Chris showed you that picture and half the stars were missing? Because I
don't know if I have a theory on that yet. It's really cool. I don't have any idea what might be going on there. You'd think, water has reflective properties like a lot of things, but when you look at the daylight stuff, like you compare those photos to the daylight stuff down at that the salt flats down in South America, the Salar del Uyuni. That seems pretty good, but maybe there is some issue with nighttime photography. I don't know yet.
Well, I think you get a lot of lens distortion, regardless whether whether you look at it through your eyeballs or whether you look at it through a telescope or a camera. We've all got convex lenses, haven't we? So I think that does have actually quite a big impact on the actual image of the night sky. And I think it was Chris who mentioned it about the sight. Is it only when it's perfectly aligned in front of your eyesight? Is it? It might have been somebody else who mentioned it. Just the perfect view is when that's actually in front of your eyes.
There is a tiny spot in the human eye that doesn't really see anything at the center because everything kind of converges to a single point. Lenses will kind of do the same thing, but we compensate for it. Yeah.
I just thought about something. When Chris has been showing these pictures, he'll always say, yeah, but look, the mountains exactly in the water, the trees are exactly the same in the water, but the stars aren't.
That's why I was bringing up an image here too. Yeah, like the mountain is perfect, the trees are perfect. Yeah.
I know what Karen was saying as well.
Just be the lights too weak.
The magnitude of each star might have a little effect on that as well. But if you can get like a bright star, then you can get a dim star, and you can actually not see the bright star, but you see the dim star. That would be interesting.
I'd have to say something to do with like an exposure problem with the camera. Maybe it's something to do with like the exposed light off the waters. It kind of diffuses it, or even
waves in the water, maybe.
Yeah, you got to look at the stars. It's like magnifying. Are they the like bigger magnitude, the brighter ones, or I don't know? It's something to look at.
The water looks quite flat there, though, doesn't it? They wouldn't be able to take perfect pictures of the stars if the water was moving, would they? That water looks pretty still.
Yeah, water's always flat, Karen.
It's always moving, though. That's the thing. There's never still.
There's always a breeze.
It is flat, Dave, but yeah, it has currents.
If it was a breeze, though, it would create a wave, and that would distort.
Mm-hmm.
Yeah, that's why I'm going to use a mirror.
Yeah.
You need somewhere where you can see the Milky Way like that, though. Somewhere zero light pollution. Isn't that
Yeah.
Well, it should work if you got a decent shot of the sky. I mean, if anywhere where you can see something recognizable, like Orion that has, a specific formation, take a picture of it on a nice clear night, put the mirror towards it, turn around, take a picture of the mirror. And if you see any stars disappear from Orion, then that's your answer, right? In a mirror.
I've never actually seen it with my own eyes or on a second photograph. So it'd be interesting to somewhere where there's less light pollution and actually try and get a shot of it.
Yeah.
I suppose we haven't actually said to Mark, Chris, Dave, Mike for sure, Stan. I'm not sure if Tom and Thompson's been talking to us, and so has Turquoise Dragon, but they've all gone for the NASA that it's debunked. It's completely wrong. So this is what they're talking about. They know that it's completely wrong. There's just no way it can happen. They've exhausted every avenue, I think, of trying to work out how this could work to make a globe, and they just can't do it.
Well, talking about the eclipse.
Yeah, sorry, back to the eclipse. Whoops, sorry.
Sorry, I didn't know what you were talking about then.
Oh, they're probably watching us for ideas,
Yeah, it could be.
I wouldn't be surprised.
Yeah, say hello. All right, NASA, give us
Why
back
not?
our money.
Put it out to the hive mind. I have been surprised pretty much every week by somebody's observation. They pick up. I kind of joked about it, but I said, look, all it takes is some guy in his underwear at 3:00 in the morning in the middle of Nebraska to see something that nobody else saw. Like, oh yeah, by the way, that thing in the corner of the screen, that shouldn't be there. And then he puts posts it out on the internet, and it sticks, and then it goes viral, and it takes a hive mind, and I think the hive mind is misses nothing. It's amazing the level of detail now that once they focus on something, how they can pick up pretty much everything. It takes a little time, because everyone, the spotlight tends to shine in one area, and people keep looking at that area. But there's other people that just aren't interested in that. It's like, yeah, I'm going to look over here, and they're the ones that find the gems. I get emailed gems every single week. It's great.
Well, that's good then that people are telling you. Can I just ask you, Stan, how far do you reckon that your 360-degree camera sees, by the way? Because I'm just very interested to keep telling people these cameras can't see that far.
93 million miles.
Yeah, I can see the moon, so
53 billion light years.
It sees all I need to see, and that's good enough. I don't know exactly. I've sent it up on the drone, and I can see some distance. It must be 50 miles, 40, 50 miles. But
the other thing, Mark, that we've been talking about a lot is that it comes up in your perspective, right? It's traveling like from obviously the east to the west, but that's only so many miles, and yet it takes hours and hours to do that in your perspective. At the same time, it's up in America doing the same across very slowly for hours across your head and across.
Oh, right. But are we talking? We're still talking about the eclipse, or just talking about the moon in general?
I said these are the things we've been talking about lately as well. Is that the sun takes hours in your perspective to go across, and yet it's doing the same thing somewhere else.
Right. In fact, I was watching a video today where, because the globalists, they'll still hammer on us about how there's, they say, well, the sun. Remember, people really, it's the simple concepts they have a hard time with, because they can't let go of the conditioning. They say, well, the sun's obviously an omnidirectional light source, so even if it was smaller and above you, you're still going to be able to see it everywhere. You're not going to have time zones. And I keep trying to tell them, going like NASA and all the science and astronomy books, how the perspectives are wrong. They condense the solar system, try to squish it into one page, even though from their model everything's really, really spaced out. You got to remember that in our models, the sun and the moon are so tiny. In fact, I've got some physical models here that were sent to me by Chris Pontius, and even the light source in that one, which are tiny LED bulbs, are 4, 5, 6 times larger than they would be in for what we think they actually are. 50 miles, that's nothing on a giant map. That's just a speck. That's a tiny light source. And when you think of it like that, and when you see it in real life, when you see it firsthand, the lights, if it's a directional light source moving around, not the computer generated one, look up Chris Pontius, the physical models. The physical models work exactly like the computer projection that we have, where it just goes off into the distance. So yeah, it's easier to imagine. Remember, a picture is worth 1,000 words. And once people see it for themselves, they get it. But sometimes it takes a while. You have to hammer it into them. What's the repetition is the key, which is why I know I bug people, because I have to repeat myself in interviews and stuff like that. But that's how you drive it home.
Thank you for that. Can I ask one question, just changing the subject again, back to your trip out? Did lots of people start recognizing you when you were out, by the way?
That's really strange you would mention that, because just before, everybody in the Seattle one pretty much did, but that also had helped. We kind of cheated there, because D Marble introduced me at the beginning of that meetup. He literally brought me up first to the mic and was like, "Oh, okay, well, I'm Mark Sargent." I should have made up something my name is IPS, or I'm Matt Boyland, or something like that. But what was interesting was, and I'll share some quick stories, and I do have to go here pretty soon, because unfortunately I've got to prep. We're letting the production team stay at a guest house, and I've got to. It's my responsibility. I have to make sure the place is perfect for it. But I want to share these stories. When I was just before I went to the Seattle meetup, I was down in Atlanta for I was attending, not speaking, at a religious. It was a biblical flat Earth conference, and it was between Zen Garcia and Dr. Stephen Pidgeon, and they were going toe to toe. And there were quite a few people there. It was 60, 70, 80 people. I can't remember exactly how many people were in the audience, but it wasn't a meetup. These were shared seating. Lots of people, and quite a few people did not recognize me, and so they were just there for the biblical meetup. I was there just attending. I was not presenting, and because outside of Patricia's show, a lot of people only know me for my voice. So unless I'm talking, they don't know who I am. So at the last part of the first day, I made sure they opened it for questions, and people just lined up. It was fascinating. People literally just lined up for the microphone to ask the debaters questions. From either side, I made sure I was the last question, and I asked them something about the Tower of Babel. But I introduced myself, and then people came up to me, afterwards, and took pictures and stuff like that. But here's the interesting part. When we had the lunch break on the first day, we went to a restaurant that was literally right across the street from the hotel. Literally right across the street. I mean, you could throw a rock and hit it from the hotel lobby. The waitress that was helping us, she was doing her thing. And then one of the bartenders, a girl who was maybe 25, 27, something like that, she came over. There was only 4 or 5 of us there. They were at that restaurant. And she goes, "Hey, are you guys flat earthers?" And I go, "Yeah, why?" And she goes, "High five," right? And she was so excited because we were flat earthers. She had no idea there was a conference going on. She was just one of those hidden flat earthers. I've always said that 90% of this community is out there, and you don't know who they are, because it's not like we're wearing badges or funny hats or anything like that. You just know you're probably walking by flat earthers all the time on the street. Here's where it gets creepy though. I'll end the story on this, where when I was leaving, I was going out of the Atlanta airport, and in the United States, they check your bags. I don't know where they do it overseas, but your bags can sometimes get a secondary screening. So it goes through the x-ray machine and then gets put in another conveyor, and somebody else secondary screens it. And I'm sitting over there waiting for my bag, and it's going in the secondary screen. I'm going, "Oh, great. Well, there's nothing in it, so who cares, right?" And I'm wearing a shirt that somebody had sent me. You've probably seen it. It says, I am Mark Sargent. It was that meme that I'm not terribly fond of, but I'm glad it's getting the word out there. But it just says, "I am Mark Sargent" on it. And this kid, he couldn't have been more than, black kid, couldn't have been more than 25. He looks at me, he goes, "Is your bag?" And I go, "Yeah." And he motions me forward, and he looks at the shirt, and then he looks at me, and he goes, "So you Mark Sargent for real?" And I go, "Yeah, why?" He looks around, and he goes, "That's my name too." Wink. And he hands me the bag without even checking it. I was going, "Are you kidding me?" So there's 100 security guys in this place, and this kid's a flat earther. Not only is he a flat earther, but he knows the meme, and it reminded me that's straight out of Fight Club. Where the bartender with the black eye gives you a free drink because he knows you're in Fight Clubs. Like, holy smokes. It was really cool, because as I was getting on the plane, I realized that this thing's even bigger than we think it is. There's a lot of people out there. It's let me you've heard me say this before, but I got to repeat it, which is, it reminds me so much of that Spice Girls joke. You guys know the Spice Girls really well, which is, this thing won a Grammy, their big album, "Tell Me What You Want, What You Really want," that whole thing, won a Grammy, millions of copies were sold, and nobody admitted to owning that album. Nobody. So that's what the Flat Earth is kind of like, where it's Flat Earth is that record you play at home for yourself, and you never tell your friends you own it because you're afraid of what they might say. Who is sharing that?
Yes, it is something like that, isn't it?
Yeah.
It is something like that.
Oh, that's me just listening to you talk. I'm like, oh yeah, this is straight out of like They Live. Rowdy Roddy. It's like right on, Rowdy Roddy, go.
Yeah. I'm not kidding you. When this thing finally cracks open, there's going to be people standing next to other people, and they're going, "Can you believe this?" And there are people going, "Yeah, I can totally believe this. I've been in this for a year and a half, or whatever it is." There's going to be lots of people that that know, but they couldn't tell anybody. How could you? So that's why we're trying to come up with subtle little things. I don't know how.
I think everyone spoke to someone that's spoken about Flat Earth, or everyone's heard something about it.
Yeah, you're absolutely right. The degrees of separation are dwindling. What is it? I believe it's 6 degrees of separation, where everybody's connected within 6 degrees of anybody else. We're way down there now. We're within, if not 1 maybe, but 2 degrees. Here, real quick one. There was a friend of mine who's working out in Colorado. She's working at this big company, and a coworker who she didn't really talk to much. He comes upstairs and he was talking to her about how her kids were doing some map project at school, and he was a flat earther, and he thought he'd mess with his kids, and so he drew him a flat earth and map, and the kids were giving him crap, saying, "Dad, that's a flat earth map." And he was relaying the story to a friend of mine, and my friend, she goes, "I know a flat earther or two," and he without even blinking, he goes, "It's not Mark Sargent, is it?" And she goes, "It is Mark Sargent." And so it's like there's all sorts of different ways. Like the waitress, she didn't know who I was. I go, because I asked, I thought I'd tease her, and I said, "Who's your favorite flat earther?" She goes, "Oh, I don't know anybody by name yet. I'm too new." It's like, that's great. That's fine.
In America, do people, when they recognize who you are, come up and actually touch you? They have to touch your hand, hold your hand, cuddle you.
The meetup I did in Seattle was a lot like that. Yes, a lot of hugging, a lot of handshakes, nobody crying or anything like that. Nobody screaming and trying to tear off my clothes. But there was the feeling of the smiles of what were really great. People are just so, it's like, they're just so happy not only to meet somebody that shares their views, but somebody that really helped them. I mean, I heard the most wonderful things where people's like, you really helped me. You really helped me open my eyes, awakened me, woke me up, all the different versions of that. And so that part's great. It's fantastic. But again, I'm just along for the ride. I'm just one person in this whole thing. I'm glad that I could create.
People know who you are. I feel like they know you, don't they?
Some more than others. Some more than others. Some people know because I've done a lot of different things where people have asked me enough questions where, if people follow some of the interviews, they know details that I've probably forgotten. But I've kind of let me end with this, because I do have to run here in a bit. The people that are going to be coming to the conference in Raleigh, I'm trying to tell people in advance. I'm going, look, bring some sort of correspondence with you, some sort of printed out email or something that I know, because if you left me a voicemail 3 months ago or whatever it is, chances are I'm not gonna make the connection right away. But if you show me something, so I think it's like, oh, I see what I did here, then I do remember a lot of that stuff. But I'm gonna give it my best. I feel bad because it's like anything. You're gonna shake hands and they'll feel like you. It's like, we haven't really met yet officially. So
well, Mark, all I'll say is look out for my moon race T-shirt, which was designed by Ken of Art. So look out for it.
Yes, because David Marsh is coming to your conference.
Right on. It's going to be really cool. Let me hype up the conference really quick. If anyone's not on the waiting list, get on the waiting list for this thing. I know they're still trying to squeeze people in. If you want to volunteer for something, I know that there's stuff available. I don't know what it is yet, but I know there's stuff available. There's going to at least 3 documentary teams that are shooting this simultaneously, probably going to be stepping over each other's toes. And the big kick for me is going to be if mainstream media tries to send people to kind of treat it like a circus. I have no doubt that there'll be mainstream media that will send people there because they think it's going to be full of people literally wearing tinfoil hats. literally people they're expecting to see just a freak show, and it's not gonna happen. I'm telling you right now. I've been to 5 meetups already. This is just gonna be a giant version of that, and quite a few people from those meetups are coming to this. Everybody looks pretty normal, hardly any facial tick or colored hair.
Painted us out.
The what?
When actually, how people think they're going Mach 80 and traveling at 1,000 miles an hour and all that now just seems stupid.
I know. And by the way, there's gonna be protests there. It's going to be a happy, wonderful, positive thing, but I guarantee there's going to be protesters there. It's too big a target to not have something along the lines of, all you have to do is get some local university students, because there's major universities within striking distance. You're going to get some science departments. We'll outnumber them, of course, but there's going to be
quite a good test then, isn't it, Mark, about how the public's really feeling and how many people are awake. And there's not the protest you think it is, or maybe it is. I don't know, but hopefully it's not. And hopefully
there'll be some. But I think is going to happen is what we've seen so far, which is I've done 100 and the one tomorrow will be 126. I've probably done more that they never released because the shows collapsed simultaneously when they tried to do it, because they thought they knew the shows were going out, and so they said, okay, we're going to end on a big bang, so let's end with Flat Earth, and then they never released the archives. But almost all of those shows, the initial response is not necessarily, usually the 5 stages of acceptance is denial, anger, bargaining, depression, and acceptance. Everyone's kind of back on their heels because it's so mind-bending in the first 5-10 minutes that they don't know how to react. If you're a radio show host, because you're conflicted, you don't want to lash out. So I would think that's the sort of reaction we're going to get from the people around there. It's good, kind of like the articles that have been published recently. It's so interesting, and yet it's so new. Even though it's one of the oldest things of all time, it's so new. They don't know how exactly to feel about it. So their first response is just to listen, which is great. It's all right, fine. Here's our pitch, and then that's how we get them. That's how we've gotten a lot of people. Maybe even some of the people here. Anywho,
let's just hope it's a really happy occasion for all, and there isn't all that happening.
Right.
Say 2 things before you go. I messaged Patricia before and I asked her, because obviously I asked her to come back and she said she'd come back, and I've messaged her. I don't know if she's looked at her message yet, but I said if she came on, maybe you'd come on with her for a bit.
Patricia. Sorry, it's not ringing up. Don't.
You know who she is.
Blonde? No, wait.
No.
Brunette? No. Okay, no, absolutely. Are you kidding? No, Patricia'd love to come on. And yes, and I would, if you can get her on, you know how that's going to go. You didn't even have to ask. She'll probably just, hey, would you want to come on the show? It's like, yes, fine. I know you're doing like 8 things, but come on, please. It's like, I can't, it's tough to say no to her. So yeah, I'll do it.
That's brilliant. And then I know you've got to rush, and I know not everybody's got cameras, but you're leaving first of all, and we always have a group hug, Mark. So Mark a hug. You've got to come back and give Mark a hug. Patricia.
Hey man, Patricia's not. And who's the moon guy again? Oh, hey, wait. I can't see the shirt. You got to talk when you're showing me the back of the shirt. Wait, you got to talk. Your microphone's muted. It's a rookie mistake, and you hate to see it. No, your microphone.
Right,
now. No, talk and spin.
Yeah, it says research NASA hoax.
Okay,
basically, the T-shirt is Trappist 1. Yeah, do you Tetris, bro?
Nice.
It's the image from the Hubble telescope.
Nice. I'm getting a whole battery of special shirts for the conference. I don't even know what they are exactly. People just send them to me.
You like your T-shirts and hats, don't you, Mark?
I do. I've had these are 2 custom hats I've had. This one is a gray or a monochrome United States flag. It says Whidbey on it. WHIDBEY, which is the island I'm on, and then the other one is Whidbey Island, Washington, just for people that don't know what Whidbey means. So, and my Canadian hat. So, trying to, if I find any more flat Earth hats, I'll get them. People want to send me flat Earth hats, I'll wear them.
Did you hear that, everybody? If you've got a flat Earth hat, to send it to Mark Sargent. Anyway, we're all here. We're all here.
Like that makes a difference because everybody's far away. You actually did that. You're like, hey, everybody.
Oh.
Wait, so who's the moon? And by the way, hi, Patricia.
Mark goes to his post and he can't cope with the hats now, and you've got to wear a different one each day.
Oh, no, it's going to be tough to do.
The moon's Stan.
I'm sorry, what?
Stan.
Oh, it's Stan with the moon?
Yeah.
Yeah, it was me, year.
Very appropriate, by the way, that you have a moon before the eclipse.
Oh, that's been my picture now since I started all this. Not like about 2 years back. Yeah, started looking at the
Nice.
sky.
Well, we'll have to see what happens Monday. If I don't talk to you guys before Monday, depending on when you do this, have a happy eclipse. And remember, no matter what the mothership broadcasts, don't believe it at face value. Just saying.
Yeah, no, because Mark thinks that they're going to probably try and do something that day. So whatever happens, it's not real.
Cool.
Can we give you a group hug now? We're going to give you a group hug because we're all here. So we're giving Mark Sargent a hug, and thank you so much for being on our show.
I'm gonna laser all you guys right now. All right, guys. Thank you for having me. I'll talk to you soon.
Bye.
Yeah, Mark.
Take care.
Bye, guys.
Take care,
Thank
man.
you so much.
Bye, Mark.
Bye, Mark. Thank you very much, everybody who came back for a hug then. So, now Mark's left us. What do you want to talk about, guys?
Karen, while Mike's on, I would like to just run something past him because I've been working on my new video, Moon Race 3.
Yeah, sure.
Well, I just want to run something past Mike because I want to know his thoughts on it and everybody else's thoughts here because I think I've found a bit of a grey area in NASA's model, and I'd like to just put it past you because like I say, I've been measuring that culmination in the moon in the meridian passings to find out when the moon speeds up and slows down, and because NASA have released a lunar reconnaissance orbiter visual model for the year 2017. They originally only had it out for 2016, so I started building all the data for 2016, and they bloody released the 2017 one, didn't they? And all my moon observations are with 2017 from 2017, so I had to scrap all my old data and start building the new data, which I've started because it's so time consuming. It's just getting my head in the right gear for that. But if I could share the screen, then obviously show Mike where I'm up to and ask him if and everybody else if that's all right.
Yeah, sure. Go for it then. I'll present.
So I just share the screen as normal then, yeah? Your entire screen or
application
window. It doesn't say share now though. It only says share when I've got entire screen on. The actual share goes off when I've got the.
The application is the second tab.
You're showing the
Should I cancel it?
do the application if you can, because you show the hangout otherwise.
Yeah, you see only the full screen because you're in the first tab, but the second tab contains all your application.
Right, so the second tab, you say. So I click the second tab, yeah, but...
And then the particular application you want to share. Maybe you need to open it first.
Page, Dave.
Right, so I've got you now, yeah. Will I be able to share a video on this as well, like in this actual folder? Yeah.
That's it.
Right, so...
Oh.
Where is it? Right, so what I'll do first, I'll just show you the actual working model.
Yeah, the video.
Is that working?
Yeah, you're still in the same share. That's the whole point with application. First, open your video and then share the video.
Right, sorry. I thought you said open the screen, then share it. Should I stop sharing again then?
Yeah, stop sharing and then share, and then choose the video player.
Right, I've got you now, yeah, sorry. So...
It's all right.
Don't
worry, Dave.
Did we have to do this before? Because I can never remember doing this before. Or is this...
It's just for the protection of sharing the Hangout key.
Right, got you. Right, so then you share the application window. So I've got you now. So if I open the video as well and just pause that.
Bear with us in the chat room.
So...
Okay, that's what.
So this is NASA's model from the 1st of January 2017 right through to the end of December.
It's black, Dave. Dave, it's black.
Yeah, it's black. Are you full screen? Just keep clearing the normal window.
Try one more time.
Well, try not to share the link as well, Dave.
Yeah, well, I'll just put it in the application window. Yeah.
Yeah, that's the one. Actually, Chris Truthseeker does a really good video on showing people how to screen share and stuff.
It's still black?
No, you're sharing the window of the player. I'm not sure if it's played.
It should be okay if you hit play, right? It should play.
Start playing.
Okay, press play then, see what happens.
It is playing.
Yeah.
Yeah. Oh, that's it. Saw it then. It's gone now.
That's strange.
We touched something and we saw it.
Yeah, I pressed the play button. Let me just double check that window again. So,
is there any way you could quickly send the link through and Series will do it?
It's actually on the hard drive, isn't it? So.
Okay. Have you got the screen up, like over the top of it? You have to put a screen. If you've got another screen up, you have to put that screen down.
The only screen I've got in front of me now is the media player screen.
Okay, it's not showing itself.
Full screen doesn't work.
Let me just try one more time. Then.
There's always got to be something technical, hasn't there, guys?
I don't know if you have.
I click on the screen share, I've got 3 windows open now. I've got the actual window of my hard drive folder. I've got the Windows Media Player, and I've got the Google Hangout. So I click on the Windows Media Player. Yeah.
Media Player has troubles. It seems it's catching the video screen from the Hangout itself away. It destroys it. But VLC Player is a good one. VLC.
Can you see that?
The window, not the video.
Oh, I'll give in then. I don't know how to do that. It don't matter. I'll show it another time, maybe.
Different player.
Yeah, I haven't got any other players installed on there, so I'll show it another time. Like I say, it was very simple last time. I literally just click the share button. But I'll leave it anyway.
I don't know what to suggest, unless you carry on.
Yeah, not
if you take the Google Hangout page, like your Explorer, Internet Explorer page, and slide that, just grab it and slide it all the way over to the right or left so you can't see the Hangout address, and then open up your player, play it, and share full screen so that it jumps in behind it. That might work. Just
Thanks, Chris.
Fast switch.
Since David brought up the LRO, the Lunar Orbiter, I put in the link for everybody, the debunk that the thing even exists. One is NASA's LRO photo, and the other is the Epic Discover photo that NASA recolored and pasted in over a model of the moon surface. So, and both those are links to NASA archives. Debunked. Buddy wanted those links to debunk the LRO. Now, some people will say, well, it was on the same day, so it would look the same. And some people are saying that, but then the moon is missing from the Epic Discover photo, if that's the case.
Thanks for that, Mike. How much disproving do we have to do then?
Karen, I don't know. You can send them something like that to 2 different archives to prove that NASA is faking the LRO, and people still have an excuse. So I don't know, Karen. I don't know.
Sorry, carry on. Somebody who's going to talk.
I was going to say I think it's important to play the game and burn the candle at both ends, right? You spend a little bit of our time just obviously doing, showing how the globe model fails to function, is completely dysfunctional, has no scientific basis whatsoever, while also developing a new science applicable to flat Earth and actually what science really is, and have the two kind of meet in the middle eventually. Right? Play to both sides.
Yes, Chris, sorry.
Yeah. That's what I enjoy the most, right? I enjoy that the most is because you learn so much more about what science really is and natural science is and how the thing really works, right?
It's people like you who's putting it together, though, isn't it, Chris? It's a bit like science. There's a bit there, there's a bit over there, there's a bit in another bit, and a bit you can't see around the corner. And they've segregated it all up and made it almost impossible for anybody, unless they're researchers, to actually work this out. And then there's people like, Thomas Johnson's the same, Stan's the same, Turquoise Dragon, Series, Mike, Eve, and you.
Yeah, and I can't stress enough. I always stress to people to take your time, do your own research, because nobody can think for you. Nobody thinks exactly the same way you do. Nobody will see it the same way you do, but figure it out for yourself, right? And that process of just questioning, and then take the time, do the math, do the calculations, figure out some basic electricity, understand a little bit about optics and telescopes and refraction. Take the time to learn about it, and that process will teach you so much more than just accepting somebody's word, at face value in either realm, right? Right. I mean, you obviously made the mistake to accept the globe model without questioning. Well, take the time and use the flat Earth to question the globe, and you'll learn so much.
Karen, it says I'm presenting to everyone, but I can't see anything on my screen.
There's just your face, Dave. Your face is just up. Oh, it's so annoying, Dave. I know you want to show it.
No, I was just trying to get out of the presenting screen. That was all. I was still presenting it. That was it.
Oh, okay then.
Have I stopped presenting now?
Yeah, you stopped presenting. Can I just say for everybody in the chat room, we all know who you are, and some of the people in the chat room will know who you are, but I wondered if each one of you will just explain what you've been doing, around flat Earth, around the eclipse. I don't know, we'll start with Turquoise Dragon this time.
All right, got to jump to unmute myself first, don't I? Just more of the stars, really. Time lapsing, really, because I work nights. So I'm in work when the stars are out, you see, so I find it hard to capture them. So my days off, I try my hardest on the clear night to get some nice footage, and that's what I'm doing now, as well as putting it out there that what we should see and what we might not see, and just planting these seeds. Even if it's these doubt seeds, you know what I mean? Because then once people are like, no, the shadows. Wait, hang on, how does it work again? I'm trying to brainwash people to think for themselves. please somebody help. That's basically just here and there really. It's been busy really.
If you're into stars, caught that thing that Chris was showing you, stars don't appear in the water the same as they do.
Yeah, I heard about that. Yeah, it'd be really interesting to. I was thinking it'd be an exposure problem or something, but would there be less light refracted or reflected off the water surface to not be like in the bandwidth of what the camera's capturing? Maybe that's probably it. I don't know. Something to look at.
Well, thank you very much for doing all your research. So
thank you.
And you keep posting it on my group, and you'll come back and you'll talk a bit about what you do. So that's brilliant. Thank you very much, Turquoise Dragon. What about you, Stan?
Well, sorry, you have to repeat.
Oh, the question, like this whole thing about what it is, this whole flat earth thing for you. What is it you do? What is it that you try and show people?
Well, I just show them what I see, and what they take from it is up to them. I don't want to tell anybody, what they're seeing. I want them to come to their own conclusions. I don't want to ram nothing down anyone's.
Use this camera.
Yeah. Like this technology, you've only been able to have it like the public the last few years, so it's new. You couldn't do this 10 years ago. What we're doing now.
I'm glad that they did in a way, because otherwise, it seems I've got to a really positive part here with all you people. I'm so proud to be here right now with all of you lot. And just to say again that Stan leaves a 360-degree camera up on in a second bedroom upstairs.
No, it's on my roof. It's actually attached to my chimney outside. I have to climb out of a window into my valley and then shuffle along the valley up a chimney, and it's on top of the chimney with a big cable going to it, and then it's hooked up to my laptop. Yeah, you have to be dedicated to find out stuff, And
the other part you've been masses of work on is this Eclipse, isn't it?
Yeah, Z-Proxy's been modelling the Eclipse in the VR, and there's still problems. It's mainly shadow problems, and the direction, we've got it going the right way, but it's not travelling exactly the right path that they're showing, and it has to match the sky. So we're filming the sky. We've worked out where the moon should be on the ball, and it's all how it should be, and it's not right. So
thank you for all that you do, because I know that now you talk to, well, you're all talking together, aren't you lot? Jay, Chris, Mike, you're all talking together, and it's really brilliant to be here while you're all working so hard to.
Very well, Karen. There's a few of us on here which have met on Facebook first, and this is the first time I'm kind of talking to Dave, talking to Thompson, and that. It's cool. It's cool.
It is. You're here, boys.
Yeah.
Mike, it's your go, Mike.
Well, I like Stan's approach. Show them stuff, let them draw their own conclusions. I have a different approach. I like to keep things super, super simple. So even if I know something by observation or talking to you guys and you guys showing me something and it's too complex, I just don't share it if I can't explain it, as we talked some other time, Dr. Seuss terms. Now, the only problem is doing it that way where you're telling people what they see is that if you're wrong, you kind of look stupid, and so Stan's able to avoid that. Unfortunately, I am not. And this whole moon thing, what you guys said, the eclipse, according to the heliocentric model, does not work. And the biggest problem is the shadow and the path of the shadow. Now, does it work good enough to make videos about it and say it's wrong and debunk it? I don't think so. But when we see the eclipse, and if we can get an airplane view above the clouds, I think what we're going to see is a big, long, angular shadow, which is totally impossible according to their model. And I think we're going to see, and I think the shadow is going to spread out in a big angle, and their eclipse can only be, at best, considering the sun rays could actually reach Earth, as small as the sun is to our perspective, which the rays wouldn't. But let's say they did, the shadow would be a small, round little shadow, and that's not at all, I don't think, what we're going to see, and that presents a big problem. That's what we model, and it just doesn't work. Now on the same token, if you want to flip it around, I've been trying to model the physical model, trying to look at Wolfie's eclipse, his moon eclipse, solar eclipse in Australia, and I come to find out that you can't physically model this thing. And so that's why when I see Chris on at 2 a.m, and I'm like, I wonder if he'd mind me bothering him. So I say, hey, Chris, you busy? So we end up talking an hour all morning, trying to wrap our heads around this. And it's just, the more you research, the more you realize that we don't know anything. And so just to plop something down on a map like the azimuthal equidistance, have it spin around and say, well, there it is, guys. Well, no, it's not there, because that doesn't work at all if you actually go into research and ask questions, because then, that leads me to like talking to David Marsh for, almost an hour on Facebook this morning. I'm like, David, what's going on with this? And then David and I are trying to correlate our thoughts together. And finally, we understand what each other's talking about. And we're like, and we don't come up with a resolution. We come up with, it is crazy. I don't know. And so now we got that. And so when we're talking about the moon and how it's going to affect the eclipse and what we know now about how the moon mirrors on the equator, I'm just like totally, maybe need a vacation and then check in somewhere, play video games all week. I don't know. But that's what I've been trying to do. And I'm going to debunk the heliocentric model with many proofs. But when you ask me about my own model, I have to tell you, I don't know.
You don't know? I thought you'd been doing the model.
Right. And the more I know, the more I didn't know. Earth repeats. I know that it's square and has corners, but how it all works, no clue.
It just used to be one of them problems where, like I say, where you can get 3 parts of the puzzle in, but that 4th piece never fits. You know what I mean? Or you get that one in and another part of it.
Yeah, where's the 4th wall? Yeah, exactly.
Yeah.
I was going to say, we have a good idea how the sky is actually working, but you're going to have to put up your cameras and get the data for us to work with so we can draw a bigger picture of what is actually going on.
Well, what I try and do is, like I say, I just try and present stuff. I don't try and say that is correct. I say, I say what I believe, and let people draw their own conclusions on that. Sometimes I will try and push things like I say, that is happening. When certain things are pretty observable and measurable. Somebody want to say something?
No, I was just going to say, with Series, what he's doing and what Chris is doing and Z-Proxy and what everyone's doing.
Exactly.
We should be able to come up with something that is pretty damn accurate.
But you got to remember, people like me, I'm not a scientist or anything like that. You know what I mean? I didn't know anything about anything 2 years ago. A lot of the stuff I've learned has been learn as you go.
Yeah, we're all self-taught.
Yeah, so
I just bought a P900 and went out and started filming, and then I've met, like, wow, look at us now, like how many people there are that we all talk to, and it's all a common ground that we share,
Yeah, but what I hope I can do is I hope one day that I will be able to find a piece of the puzzle, you know what I mean, and somebody else will find a piece of the puzzle.
You have, okay?
Well, I probably have, like, you know what I mean. I found little bits and bobs.
Could you explain to the chat room a little bit about your research then, because you're a moon man?
Yeah, well, I started shooting the moon probably about a year and a half ago. You know what I mean, just taking photographs and doing moon syncs. And then I was on the actual circle model, the AE map. I was doing my research based around that model. And I had quite a few heated debates with Darren Nesbitt. And I basically thought up about the moon race experiment, about, obviously, if I record the moon as it enters my screen on 3 separate occasions, namely the tropics and the equator, if I can back that up with data from time and day, and I can prove that the moon is speeding up in its cycle as it gets solar declination, then I'd be on to a winner. But as most of you are aware, after my first moon race, I had to basically say that the outcome of the experiment was inconclusive, because the moon did what it does. It sped up on from the Tropic of Cancer to the equator, which got me a bit excited, because I presumed it was going to speed up when it went from the equator to the Tropic of Capricorn, but it slowed down. Yeah. and that got me scratching my head. And I was like halfway through the, I shot the video and all that, and I was halfway through making the video, and I got all the little bits and bobs together what I needed, and I was just waiting for that last shoot of the moon on the Tropic of Capricorn, and it slowed down. So that basically got me rethinking then. So I put the video together, and I just left it as being inconclusive. So
I was going to say to you, Dave, we did the AE map, we were syncing on an AE map. That's what we thought. And we were going back looking at what we were seeing, and it was like, this just can't be we can't be seeing it on, it's not right. It's not working, and we were at it like that for a long time. If you go on Z-Proxy's channel, there's actually an app you can download on his about page. And if you upload your moon videos with the correct data, you know, like you have to put the year, then the month, then the day, and then the time. It will actually bring up where the moon is on an AE map, so you can see where you're looking from your perspective, and you'll see that it sort of works for the north, but it doesn't.
Yeah, everything works for the north, like.
Yeah, but it doesn't for the south.
Yeah, the south is completely skew with, and like I say, I've put it out there on a number of occasions that the tip of Argentina gets 17 hours daylight on their summer solstice, which how you'd model that on the AE map is beyond me.
Well, you get a 24-hour sun north, and you get a 24-hour sun in the south.
Yeah, we know that, but people still stuck on the AE map. I'm just, like I say, there was a good video put out by Thrive and Survive the other day. It basically showed you the AE map and how the moon or the sun and the moon wouldn't have to speed up, because he based it on like a clock hand, and they had the sun there, and then when it moves, it's still taking that same amount of time to do the full circle, but regardless where it is on that actual line. So that's an interesting point. But like I said, my question were to him, what I put in the comments was, yes, but how would you get 17 hours daylight on the tip of Argentina? Even obviously, if it was closer to the centre, yeah, and it's covering a bigger area, then you would get the 24-hour daylight. But as it spreads out, you wouldn't get the 17 hours daylight in, I can't remember, is it Ushusasi or something? But like I say, that place in Argentina, interestingly, only at 54 degrees south, is the furthest populated city on the plane. You know what I mean? There's nowhere else further than that where you can actually get observable data. Anywhere after that, it's like obviously.
Well, that's what we're told, Dave.
Well, like I say, you know what I mean. I just put into Google search the furthest populated city south, and it come up with Ushusasi in Argentina, yeah, which is equivalent to the UK in the north, which is, you know what I mean. You've got Svalbard at 77 degrees north. You know what I mean. You go 77 degrees south, you're bang on Antarctica. You know what I mean. So, like I say, just looking at that little bit of data there, you won't be able to have 17 hours daylight in the south, and for the sun to rise south of you as well, like it does, like we're above the tropics, but it rises for us north in some extent. You know what I mean? It comes at like, I don't know, 40 degrees northeast, and it's visible for 17 hours on the solstice, and it's exactly the same. I don't know if you've seen the image I've got where I've got them both on the solstice. You've got the exact same amount of daylight, the exact same amount of hours. It rises at the same time and it sets at the same time in both locations. It's identical. There's not a minute between them. If you get that time,
that's what we expect to see.
Yeah, that's like I said, that's what we expect to see, because it's basically split into two halves. It's basically identical, the other half. You know what I mean? I think it's just a landmass what's actually changes. I did check the weather temperatures as well, you know, for the annual temperatures in both locations, and the tip of Argentina is a lot colder, but it's a lot higher up, so they obviously get the cooler temperatures there. But throughout the year, if you match the days to each like summer solstice or winter solstice, it's the exact same daylight hours, which is interesting. But going back to the moon race, obviously then I did a moon race 2 video where I delved a lot more into the actual research itself, because I didn't want to only say yes, the moon is speeding up. I tried to explain why we're doing the things that we did. You know, obviously bringing in the ether to it, and the vortices, the north and south, and the celestial equator, and how it actually passes from one to the other. So I tried to actually include some more, because every time, I'm not sure everyone else is the same, when you're making a video and you start getting the information and you start building it, and it seems to be getting bigger and bigger and bigger, because it originally started off as a 10-minute video and it ended up being nearly half an hour. So it sometimes, as like I say, as you're researching it and you're getting more information, you need to add this information. You know what I mean? And to be honest with you, I had a lot of comebacks on the Moon Race 2 video to say you're completely wrong, because I did include all the source data for people to say, you know what, go and check for yourself. If you can prove me wrong, then do so. But you know what I mean? I'm not.
You made us You made us go back and look at it, Dave. Like we were like, I don't know if he's right. So we went back and looked at the full moons, you know, and there is a definite jump there. There's something. There's time difference.
Oh yeah, there definitely is. Like I say, I mean, you can record it on your screen and notice itself, and then you can compare that with the meridian passings on time and date on the following night, and you will see the difference. Like I say, and it's that same pattern all the time. It speeds up, slows down, stays the same speed, stays the same speed, speed up, slow down. It's constant throughout the years. It doesn't matter. You know what I mean? There might be a minute or two in the differences, and it's same from every location as well. It's not just from the UK. You can't just say this is Northern Hemisphere perspective. This is the same when you go to New Zealand or when you go to Ecuador or wherever you go. It's relevant to the actual location. It's still doing that same speed up, slow down pattern. So, because I know some of the comments says, well, it could be like just parallax. You know what I mean? When an object's further away, it would appear to go slower. And to be honest with you, there is actually a noticeable difference when the moon's got southern declination. It shrinks slightly. And if you compare it when it's on the top of Capricorn at the exact same zoom, which was times 60 optical, because I've only got the times 60 optical camera, and you can see quite a significant difference in size. You can see as it shrinks as it goes from the Tropic of Cancer to the equator and to the Tropic of Capricorn. So there is actually a slight reduction in size, even though when it's on the east or the west horizon, it'll actually appear bigger due to that atmospheric lensing. So that was interesting as well. And with Moon Race 3, I'm just going to concentrate on NASA. You know what I mean? I've got their working model now. What they say is exactly what's happened. And what I wanted to show you earlier on is on their model, there isn't actually a pattern to when it's at perigee. So when it's close to the approach, it does it at different parts in the cycle, which is quite interesting. But like I've documented previously, and I've got a big list of numbers and figures on the computer from my previous collating the data, that it only speeds up when it heads towards the equator from the Tropic of Cancer, and that pattern's consistent throughout. So it's just trying to show people the actual working lunar reconnaissance visualization, and then for me to show my image backed up with the culmination from time and day, and try and show people the inconsistencies between NASA's working model and what time and date. Yeah, we should probably share the same information, but because I'm using that gap in the meridian passings, I'm going to try and debunk them with their own information, really. So it will be quite interesting. It's just trying to get that across.
I hope people realise with what Dave said, he's not a big scientist. He didn't start this that long ago. And look at how you're talking now. You sound pretty like a scientist almost to me.
Well, I don't think I do, but like I say, I'm like, when something drives you, you'll give it 100%. You know what I mean, or 110%. Something really drives you to find out something, then you'll push as hard as you can. You know what I mean? And
but that's why we're all here, isn't it? I mean, Mike's going for it. Chris is going for it. Sirius is going for it. Stan's going for it. Turquoise Dragon's going for it. And Thomas Thompson, we'll just come to you now. Your take on all this, what you do, because you're going for it.
Well, I'm not really that deep into the moon like you guys are. My main thing is attacking this from an electrical point of view, and from a mystery school point of view. I'm more into the people who are hiding the flat Earth from us, why they're hiding it, looking for signs that how they've been teaching it to themselves the whole time. The knowledge has always been here. For instance, we're just now starting to open up our understanding of fields of electrical field theory and magnetism, things like this. If you go back and listen to some of the mystery school teachings and listen to Manly, Palmer, Hall, and all these guys, these guys have been talking about this stuff 100 years ago. Manly, Palmer, Hall was talking about magnetism and how there's a magnetic field around everything. And so my thing, my activity is pretty much trying to bring all this old information that's all been there and bring it in public knowledge, because I think that's going to explain a lot about the flat Earth. A lot of people understand the Earth is flat, but they're not understanding the nature of creation itself. They're still under these thoughts of Einstein that everything's made out of magic particles. You got electrons, protons, and neutrons, and gravitons, and all these other tons. But you got all these magic particles, and that's not what Earth is. We're actually in a dielectric magnetic realm of creation, I guess is the best way I can explain it. So, excuse me, what I do is basically, when I get the chance, I just educate people these older sciences and try to make them aware that there's a lot of sciences about flat Earth you can uncover just by knowing that, this is an electric universe. For instance, like, from my research tells me that there's two poles to this place I live in, a North Pole and a South Pole. And my research says that these poles each spin in the opposite direction. And if you look inside of any magnet, as I've said before, you see the same thing in a magnetic torus. You see one pole spinning one direction, the opposite pole spinning the opposite direction, then you got your block wall, your plane of inertia in the dead center of that. That's where I think we live. But here's where it gets a little tricky. I know you guys have done this. Where you've taken a magnet and you've put it up to the old television screens, and you'll get that weird magnetic pattern on your television screen. Well, in the dead center of that, in the very dead center of that, anytime you're holding that magnet to the screen, you're going to see this black thing in the very dead center where there's no light inside of it. And it's shaped kind of like a robin's egg, or I call it the cosmic egg. So when I tell people we live on the plane of inertia, what I actually mean is we live inside of that plane of inertia, inside that black dot. And I always find it amusing because if you listen to Neil deGrasse Tyson lie when he gets on TV, he says that the Earth is kind of pear-shaped. It's a little fatter on the bottom, is what he said. And when you look at that little, that black egg in the middle of that magnet, you'll see what he's talking about. The man knows the truth. He knows this is an electric creation, and he knows all about we're in that dead center of that black egg.
Also, the contours of the Mandelbrot fractal, the contours around it, that is particularly pear-shaped.
Right. Yeah, exactly.
The fractal.
Yeah, so he's telling you right to your face, he's lying to you by telling you, you live on a ball, obviously, but he's actually telling you the truth at the same time if you're smart enough to know what he's talking about. But everyone else, they're all stuck on this Einstein's relativity theories and, all this other magic particle M theory and all this string theory, thinking everything's based on these magical particles, and it's not. Everything is a field. Everything is a field. I know they tell you that there's no such thing as an ether field. The quantum physicists like to call it quantum fluid, but it's still the same thing. It's still Tesla's ether. So that's where I come from, trying to explain that little bit of science to people. And, I believe we live on a giant bar magnet, more or less. My personal preference on shape, I know we all have our different beliefs on what the outer shape is. I do believe in a square model. However, I don't believe in the square. I believe more in the sinusoidal or Ayatollah projection, which would give you angles, because I looked it up and I found out that you have one measurement for the equator, which 24,900 miles, I think it was. Then when you look up what the circumference of Cancer and Capricorn, it says that they're the same. It says it fluctuates through the year, but basically it says those two are basically the same, and that they're basically 5,000 miles shorter than what the equator is. So if I draw my equator line out and I put Cancer on the top and I put Capricorn on the bottom, and I have to make both of these lines, say 2,500 miles shorter than the equator on each side. So when I draw a line from the equator up to Cancer, I'm developing an angle so that, the same way with the Ayatollah projection, it's going to start on that western side.
This information is based on the length of everything outside of the equator. Anything else they say is shorter, but who actually measured this? Where is the data?
Yeah, that's going to. But we know the mathematics. Yeah, I know. I often question, how can we know, the exact outer shape, especially if it's a four-dimensional. Where do you draw the international date line? How did they pick that particular place? Why that particular place? Why understand the shape? So that governments can keep one time within their government. So I understand why it's weird shaped like that. But yeah, I don't know if we can ever know what the actual outer shape is, but I guess if we understand what the relationship, what their shape is in relationship to each other, we shouldn't really be having a question about this. If we line up all the international airports, that should give us the exact map right there. You can't lie to the pilots, and whether they have GPS or not. You ain't going to lie to a pilot for 500 years and him not figure it out unless your mathematics are perfect.
They all use the ETM square. The military use.
Yes, yeah, exactly, the ETM square. But again, what about the idea that on a ball, as you go up from equator to the North Pole or equator from the South Pole, you go downward, your circumference of your circle is going to get lesser and lesser.
Yeah.
And another another reason why I like this idea, though, is because look at our star trails in the sky. In the center, right going down the equator, you got the most amount of stars. But on the outer edge, you have
circumference. One idea I have: if the circumference is really shorter, then it should be possible to actually catch up with the sun with the plane because you're circles.
Yeah.
But that never happened. It's always going as fast forward. You can't get the sun up, or catch up the sun with the plane, not even on the poles. You won't catch up that particular speed, no matter how small your circle gets. Through the idea that it is a ball, you still travel the whole 40,000 kilometers. That's my idea. They never proved that it was shorter.
Well, I certainly can't prove or debunk that idea either way.
Well, the photograph can't confirm it.
Now, we were talking earlier, I asked the question of the panel, did they think the sun and the moon were projections? I can't remember who it was, said they believed it was a projection. And I wanted to ask, do you have any clues as to what's projecting or how it's being projected or where it might be? The reason I ask, here's why. If you ever look in the old Masonic pictures of where you see them towers of Jacob and Boaz and you see the sun and the moon on each of the poles, and then you see what looks like reflecting light come down into a triangle. And then it seems like that triangle is reflecting down onto a round surface, which I'm going to assume is the lower firmament, the one that separates our atmosphere from the upper atmosphere. So do you have any ideas about what could be projecting the moon or how it's being done or anything like that?
I suppose if you were going to ask anybody to answer, because Chris has done so much work, I'd ask Chris. But when Chris is explaining it, maybe then he could just explain as well what his take on this, what he's doing, what he's interested in. Is that all right, Chris?
Yeah, for sure. Yeah, I'm just pulling up some images as Thomas is talking there too, related to what he's talking about.
Just presenting it. There you go.
Carry on.
Well, question, what did you think? But then I said, would you mind, when you've said what you think, maybe just explaining to people, like in the chat room, everybody was explaining what their part was for Flat Earth. Explain a bit about what you're doing.
Yeah, I'm kind of approaching it from a similar aspect of where Thomas is coming from, more from the electrodynamics and science and engineering sides of things and physics. Right, those are my main interests, and as well, I do delve into the mystery school histories and ancient cultures and all that. Like, I'm open to everything, theology, you name it. I've kind of looked at it all. And one thing I've been looking into lately, that I've been looking at what we might be seeing on the Z-axis flip and the eclipses and causality of that type of thing, is basically just the diamagnetic properties of light coming through oxygen and various noble gases. So as the magnetic field travels through the actual particles, since oxygen is paramagnetic, it will take on the magnetic field that it's in, but it's not a permanent magnet. It's only a temporary magnet. So it lines the charge within the molecule of oxygen right down to the atomic level, but the molecule of oxygen lines itself up with the magnetic field. And when it does that, it changes the way light travels through that molecule, because light is also magnetic, right? We know the photons, when they travel, they create their own magnetic field. So as the light passes through the atom or the molecule of oxygen and interacts with that particle, the light actually gets aligned to that alignment. And if they're all being aligned the same way, then the image appears to be polarized. So when we look up at the sky, at the moon and whatnot, and the sun, we're looking through that lens of polarization. And that has, which is kind of what I'm showing here in this diagram. So the diamagnetic material interacts with oxygen, becomes polarized through a straight line type of effect. So it's bending the light to our perspective.
Making it coherent.
It makes it coherent, yeah. It's from a scattered source of a kind of omnipresent energy as it kind of radiates towards us, and as soon as it hits into a noble gas or oxygen layer, it is funneled into a cone, and the light starts to become more parallel, parallel to that magnetic field. It takes on the shape of the magnetic field, not parallel lines perfectly, but it starts to take on that shape, and that's where we're into. And it's kind of what this diagram is showing here, and they just call that anisotropy. So anisotropy properties of light. You can kind of imagine like a fiber optic cable, right? You shine a light in a fiber optic cable, it'll go 10,000 miles, right? The light comes into it in one plane, gets aligned to the z-axis, and just becomes infinitely in that vector. It stays on that vector path. And that's kind of why I'm thinking that we're seeing the anomalies that we are. Like, if you imagine in this diagram here that you are at the bottom of a prism, right? You're at the bottom of a cone or a prism looking up at the sky through a telescope or anything, your eyes, everything has this similar type of effect. So as the light travels down through the prism, down and crosses that Z point, which is like we were talking earlier, in the center of a magnet, there's a point where it's just black light on a CRT screen. You see black light in the center. Our eyes do the same thing. And if you cross the equator, which is a magnetic line of magnetic polarization, and you cross that equator, well, the image just flips because the light itself is polarized. So what we think we're seeing, you're not really seeing, because you're looking into a magnetic field always. I mean, there's no way to escape it. If there wasn't a magnetic field, we wouldn't be here. So that's what anisotropy does. It's just the property of being directionally dependent based on a magnetic field.
Now, see, that's an Ivanov projection right there on that. That's what I was talking about.
This type of and this is actually what they claim to be the map of the entire cosmos above when they did it with radio telescopes. And that's why I'm leaning towards the sine wave map also, because it has the same sine wave properties with this zone in the middle, which could be mapped to the South Atlantic anomaly in the oceans. The dielectric plane has this spot right in there. You can actually almost see that this is the United States, this is South America, this is Africa, China. You can lay the world map almost right on that, right? The Earth map on a flat plane. And it's just a reflection of the entire sky being projected down here to us. So this, and Mike and I were talking, so it's about the Z-axis phenomenon, right? As soon as you cross that Z-axis of polarization, the image just snaps, it flips, and it happens so fast. It's like light speed. When we were looking at the video that yesterday, right? The dog runs around the circle. The dog, flips upside down. You don't even see it happen. Robert's video. Right.
Yeah, that's correct. The moon on the equator. If you're looking at top down, if it was perspective, it would slowly rotate and then you'd be getting out. And then if you're underneath the moon, the camera would flip here. It's not like that. Anywhere along the equator line, the moon flips.
Yep.
It's crazy. And I was like pulling my hair out. I was like, how is this possible? So that's when Chris got a call from me at like 2 or 3 in the morning.
Yeah.
Let me read you guys a scripture.
If you see my little green light on, just assume that I'm awake. Send me a note, and I'm happy to chat anytime.
Yeah. I was like, Chris, help! I was like, SOS. Let me read you guys a scripture, because I'm always going to pick scripture. The earth has to have ends and corners. Okay, so my earth can't have rounded anything. But let me read you scripture. By what way is the light parted, which scattereth the east wind upon earth? Now, if you look at any wind map, the east wind blows across the equator center, and it splits this way. It's parted right down the equator center, and God is talking about this light in the middle of the equator. Now, when Chris is talking about this polarized light causing a flip, I think we're going to put this whole thing together, scripture by scripture. Word of God is true, at least on my end. And we're going to show how this actually works, I believe, the scientific in which you guys are studying.
Absolutely. I think they tie.
I believe the scripture can absolutely, the scripture is absolutely 100% true as far as I'm concerned. And I believe that if you're going to find the answer, you need to look at that first, then use that to go look for your answer through science, use the scriptures. Because I'm telling you, whether you believe in religion or not, just because you don't like the messenger doesn't mean the message isn't true. When you're taking that message serious, that's how I figured it out, was by looking through all these old scriptures, all these, not just ours, all cultures. Kind of got to be open, and you might not. I'm not telling you to go worship foreign gods or anything like that, but don't discount someone else's knowledge because they're from another culture or another understanding. Our ancients knew what was going on, and they left this information for us. The problem is we have secret societies step up and take control of that information, and they decide to know what. And well, no one gets to know anything but them.
No, exactly. And I think it's no coincidence that the Z-axis down the center of a pyramid prism is exactly how the pyramids in Egypt were designed, and all the ancient temples are designed as well, right? And it's no coincidence that the base of the pyramid is exactly the length in scale to kilometers of the square map that we're on, right? And it's prismic, and you can mark it right down the equator line, and that's where the flip happens. And even the tunnels themselves and the entrances to the pyramids, we talk about those a lot. If you actually take the angles of those, they line up perfect with the refraction index through a crystal and the refractive index of solid hydrogen, like not liquid, but solid crystal hydrogen. Right? It's the same frequency. And I just tell people, if you want to know the truth, you want to look for the truth, is to go look for what Wikipedia is actually banning from their website and not allowing us to access on their website. the term electric universe and how the dielectric plasma sciences and the real sciences of the Thunderbolts project, how the land formations are formed, how the craters on the moon were formed, and everything like that being related to electricity, and the oceans being dielectric, the tides being caused by electricity and magnetism, this equatorial flip in the image of the moon and the sun, and all of it, right?
There's no way they can't have all this information about magnetism and the whole story field theory. They've known Tesla was getting ready to expose the whole thing. And like I said, if you watch the Mystery School, these guys have known about magnetism since ancient Egypt. This is not a new science. This stuff has been known.
Oh, it's this science is old science, right? We're just trying to bring it back to life, bring it to the forefront, like test back where it should be, and it's continually met with resistance. Anything to do with the electric universe or electric physics, and it will always be viewed as pseudoscience, alternate science, blah 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 blah. That's a bunch of crazy kooks. They're all electric quack, right? They have no idea what they're talking about.
And it's a trained response.
It's actually being acted.
Yeah, it's a trained response, even by people who don't understand physics. They don't understand the first thing about the relativity or general relativity, special relativity. They don't understand anything about that. But they'll jump out there in a minute and tell you how great Einstein was and all this and that. But you don't know the first thing about Einstein or anything. You don't know anything about any of this. You're just repeating, they told you on the television that Einstein was brilliant, but reality proved that his math wasn't quite there.
I think that's why they're actively trying to suppress the flat Earth movement too, is because it leads people down this path when they start to wake up and realize that
you have to discover that the inevitability
that you will, and then the next discovery is that we're sitting inside the biggest battery that we've ever known, and it's completely 100% free energy. Everywhere you look is free energy.
Yeah, we're working ourselves to death, trying to pay for our energy supplies, and we're just living in a giant pool of energy. It doesn't make no sense. You live in a giant realm of free, unlimited energy that's right there in your backyard, free for the taking, but we have to pay for it. You live on a world that's 2/3 covered in water, but you got to pay for water. I mean, everything about our world is messed up.
Thomas, two things. I'm jealous. I think it's you with the cricket. I think that's you with the cricket noise. And the second thing, someone's got crickets.
You can hear that? Yeah, I got crickets.
Yeah, we can hear it. The second thing is, Chris, tell them what you're supposed to make, how you're supposed to make concrete, but we don't do it, and all about the water supply and that. You were telling us yesterday.
Yeah, if you look back at how the ancients made the concrete in the older days, if you take volcanic ash instead of standard fly ash, and look at how those geopolymers were used in the Pantheon, the cathedral Pantheon dome that's now pushing 2,000 years old or whatever, it's actually fly ash, or not fly ash, it's actually volcanic ash and water and just some basic limes as binders and cellulose.
Hold on a second. I'm glad you brought this topic up, because I've dealt with this on my Facebook. Several people brought this up, that they theorized that ancient Egypt was fake because they could prove that this item or that item was made out of poured concrete. Do you know how long have we had that science of poured concrete?
Pouring it? Oh, this goes back to well before ancient Greece and Rome. I mean, it's thousands of years old, right?
Okay, not saying that they actually did, but since we know we can't trust anybody for the truth, let me ask the question: is it possible that these giant stones, like we find in the megalithic cities, not just Egypt, but all over the Yucatan Peninsula, Peru, everywhere, is it possible that these are just poured concrete blocks?
Absolutely, yeah. Many of them could very well be. You'd have to actually test each one to see what the geopolymer content and the amount of volcanic ash, crystals, and salt content. The key is looking at the salt content, because the ancient concrete, they used volcanic ash. You just mixed it with water, but the key is they used ocean water. They didn't use natural spring water because water was precious. You wouldn't use your drinking water and cooking water to make concrete with, right? They used ocean water. But when you mix volcanic ash with seawater, this is why the ancient ruins of Alexandria and so forth off the coast of Italy, and all the ones off the coast of and in the south here, Peru and stuff, where they found those temples under ocean water, are still there, and they're not eroding like you would expect to in salt water, right? They're still just almost as fresh as they were the day they were made, right? But it's because the actual concrete itself was made from salt water, so it's impervious to salt intrusion. It doesn't set up a cathodic effect like a natural like concrete we use these days, it lasts about 50 years because there's a cathodic effect that forms when you have rebar inside of concrete, and the water starts to diffuse as it starts to dry, because concrete never stops curing, right? It just keeps getting harder and harder until it falls apart. But in modern concrete, we get 50 years out of concrete. First is this volcanic style of concrete that lasts 2,000 years and had no rebar in it whatsoever, right? Freestanding structures, no rebar required, right?
And it would seem naturally, of course, the Freemasons would naturally have that information, since, well, that's what a Mason does. He works with stone.
Well, that's part of the, working with temperance and veil, right? That's temperance and veil. Temperance is learning how to temper, tempering things using proper temperament, and the veil is the veil of secrecy, right? Temperance and veil. That's part of that ritualistic secrecy, right? And I just pulled up a picture of that too, so people see. But looking just in plain sight, right? Here's a screen share. I mean, you were talking about the Mayan egg and the eggs, the Fabergé egg, so forth. Right? There's in your face, right?
Right.
Where's that? Downtown England somewhere? Yeah.
And then you can use that the giant cosmic egg with the serpent wrapped around it, and easily say the serpent. Now look at that there. Yeah. Now that's obviously magnetic.
Well, that's where I was going, right, with the cosmic egg and the crater type of idea with square plane inside the circle.
Yep.
And it's
that's
also
exactly
fire.
it. Right there. There's the mundane cosmic egg right there. Yeah.
And it all ties into the scriptures, and with the square and the compass and the Christ compass the earth and the circle. It's all the same story from a different perspective. In my opinion,
I think what we're calling scripture is really part of a much larger body of knowledge. But say, for instance, when we say the King James authorized version, what we're really these are the books that King James has authorized you, the general public, to study. And if you want to know more in depth, you'll have to join mystery schools. That's
I think Chris is coming to the real. Well, we all are, but the Bible is a code book. It's
absolutely master science book. Yes.
Oh, yeah, it contains a whole lot more than it contains a whole lot more knowledge than just the basic the stories and the history and all of that. There's a whole more that's multi-layered, right? There's multifaceted. There's no answer or science or anything you can't derive, from that scripture. It's coded, but you have to look for it.
Would it be right to say then that if anybody's doing some research into flat Earth and they're doing the proper research, that like many of you, my research has led me to electromagnetism. You know what I mean? That's where my research has led me, and I've come just from observing the moon. So just from observing the moon from a flat Earth perspective, it's led me to the electric universe, and I presume that's what's happening with other people. You know what I mean? They're coming in from all different directions, and we're all ending up at the same place, the electric universe. Is that? Yep. Do you think that'd be right to say?
That's fair to say. I mean, that's the inevitable outcome. Yeah.
The moment you figure out flat Earth, if you're a real researcher and you really want to know more than just what they just hand you in the video, because let's face it, when we've discussed this before, when we first discovered the flat Earth, you were handed a whole bunch of facts, and you didn't prove any of them. You never proved no 60,000 mile ice wall. You didn't prove no circling sun. You didn't prove any of this. All you saw was what they showed you in the video. But if you're a real researcher and you go out to discover how this place works, you're going to come to the conclusion that this is electric, and then everything's going to tumble. Flat Earth is just the tip of the iceberg, but it's all going to break down, because now all their sciences are going to break down. Everything's tied together. So it's definitely it's magnetism. That's the way to unravel them.
Okay, I have something to add if it's okay, guys.
Yeah, sure.
But first of all, this mic's going to have my thing off. But anyways, questions in chat concerning the azimuthal equidistance, Gleason projection, as opposed to maybe a rectangular Pac-Man type Earth. Now, here's the thing: if you love Scripture, and I do, and I value God's word, the Son of God, Lord Jesus Christ, is 100% truth and accuracy. The people I'm talking with here today, they value all the works as one cohesive truth that point to the same thing. I do not value any other works but the 66 canonical books that we consider scripture. And the point is, though, all the ancients and what Chris and everybody else here is saying, it sort of matches up with a dialectic electromagnetic universe. Kind of like how things work. Now, the azimuthal equidistance, Opikadu, or I don't know how you pronounce his name, he just jumped ship today. And his whole premise was basically debunking flat Earth, kind of like Tiger 925 did. He debunking flat Earth, he used the azimuthal equidistance as proof that the Earth is not flat. Well, first of all, the map has nothing to do with curvature rate at all. Am I wrong, guys?
No, you're right. Yeah, you're right.
Yeah, correct. And so it's just a psyop to say, well, the flat Earth map don't work, so the Earth's not flat, and that's just totally incorrect. But they're using the azimuthal equidistance map against us in ways that no flat earther can defend. And so what happens is these flat Earth channels don't answer the questions, and we come off looking like total idiots. I have a real QF 27 pilots data from a 747-400 that's Sydney to Santiago, SYD to SLC, and I got the data off as plane. The route is correct. There's no debunking it. Also, the way the moon works, we now find out the moon flips at the equator center. It just flips. And as Chris Monk explained, this is probably due to a property of polarization of magnetics. I'm not saying it's that. I'm just saying God did it for now. But I'm listening to what these people are saying, and it makes sense. And what they're saying is putting signs to what God did. And that moon does not flip like that on the azimuthal equidistance. You want to talk about eclipses on the azimuthal equidistance? Well, there has to be eclipse in South America too on that map, and that won't happen either. So, people wanting to hold on to these projection maps, hey, go right ahead. But what I'm telling you in the science is we are discovering we can't defend the map, not only scripturally, but we can't defend the map observationally or scientifically.
And that's the thing. I think they. Go ahead.
Why
I was just going to say, sorry.
Not have yourself. It's the same with going into the religion again, that you defend the religion instead of your own research. He claims the map is circle. Where does that claim begin? I'm not claiming it. I'm not claiming it's flat. I'm claiming it's square, but I've never claimed the circle. The circle was the actual map, what actually deviated me from the old flat Earth stuff.
I think the circle was just a way. I think what it was is the higher ups realized that before long we were going to discover NASA's fraud. We were going to discover the flat Earth, and I think the AE model was a way to explain flat Earth to us without exposing magnetism, because the laws of magnetism don't work on that AE map, because you would have a North Pole on top and you would have a South Pole underneath the Earth if you followed the correct laws of magnetism. That can't be. Your compass would work on something like that. But I think, again, because I believe that they consider the science of magnetism to be an even greater science than flat Earth. And that's the whole thing. I think they're willing to throw away that flat Earth secret and let us have it, as long as we didn't get too close to their real secret, which was their power source.
Exactly. What I was going to say is, if somebody out there has done their research, if a ball earth has done their research, what they'll hit you with three things. The first one they'll hit you with is the southern star rotation. Yeah. Then secondly, they'll hit you with the flying routes, and then thirdly, they'll hit you with the lunar eclipse. They're the three main things that they'll hit you with against the AE map. The southern stars, they've got this thing now where they drag like a magnifying glass over a picture of a star trail, and it splits the image into like two poles. Only thing is, that's looking from top downwards. Now I've asked somebody, can you turn the magnifying glass 180 degrees to give it from our perspective? And I guarantee you won't get the same image. You know what I mean? But you always got it with the concavity facing you, where it should be the opposite way around. So they always show that the wrong way around. So, you know what I mean? I've tried to explain this to people. Say, they keep showing that magnifying glass with the convex facing towards me. I want to see it with the concavity, because we're looking at a perspective of the sky from a bubble perspective, you know what I mean? So it's actually in the shape of a bubble where we're looking up at, but they're showing it as that way, you know what I mean? So they're showing that wrong. So, but I'd love to see that flipped over where they get the old magnifying glass and run it across a star trail. But I'd like to see that the other way around, because I guarantee you won't get the same kind of image. And also the lunar eclipse, and this is what still bothers me, me, and I'm sure it bothers a lot of people out there who's been researching flat Earth, because, like I say, there is a lot of questions asked around what's causing the shadow on a lunar eclipse. You know what I mean? I know Chris has done some good research on this in regards to it being the sun, and there is a lot of people out there who obviously believe Vedic, which is obviously referring to Rahu and Ketu. I'm not 100% sure what's causing it, and like I say, when I do eventually get past my moon observations and monitoring the speed of the moon, I'll get onto other areas. But it's like I say, I just try to concentrate on one area at first. But they're the things that the ball earthers will throw you. And I was in a debate with somebody the other day, and he drew a picture of the AE map or something, and he said this. I says, put that map, and he was like, boom, stuck. He didn't have one more thing to say to me. Once I said to him, I don't believe that map, he's like, what do you mean you don't believe that map? I said, well, I don't believe that map. And that was the end of the conversation. He had nothing else to throw at me.
And then you'll be called a troll or a shill or everything else. And they didn't do a lick of it research. All they did was watch, one of them videos that showed them this little model, and they said, well, let's admit it. When you first saw that video and they showed you the Earth was flat, you were stunned. I'm sure you were stunned. And since this person just proved to you that the Earth is flat, if they tell me that it's also round and the sun circles, I'm probably going to believe whatever they tell me, because they've already just showed me the greatest secret entire universe. So yeah, and that's how we got caught up, and next thing you know, but again, that's what I said. I believe the elite are just using that because they assumed that they already had us so dumbed down that no one was going to pick up on it, and we were just going to all jump on that little circle model, and that would have been that. But no, it didn't work out like that.
Because they just don't want you to know the truth. It's just layer upon another layer of lies. I think it's better to tell people the truth from the beginning, not put them onto another map that's a lie and then another map.
Yeah, well, I believe some of them they still believe in that map because that's what they're believing. Because what they've only done the research on the old books. Like from the late 1800s or early 1900 books. All the research has been based around them books. And if you look at terra firma, zetetic cosmogony, zetetic astronomy, all them books, 100 Proofs the Earth's Not a Globe, all them books are based around a single pole model. You know what I mean? So what they've done really, they just grabbed hold of a few of the old zetetic books, and they based all the research on them books. You know what I mean? They looked that little bit further back, maybe to Cosmos or stuff like that, and that's where I think people are stuck, because all they're doing it really is repeating what's in the old Victorian flat Earth books. Don't get me wrong, I enjoy reading them books, but like I say, there is a lot of stuff wrong with them. And the good thing is that Zetetic Astronomy by Lady Blunt in 1904 spent 70 pages correcting Rob Botham's blunder, what he'd said about the single pole model in Zetetic Astronomy. So it's good to see that they actually did realise it at one time, but obviously it never picked up. It's been pushed on the carpet. But I think Lady Blunt was onto something when she discovered that there were two poles.
Yeah, I agree with David. The old work, the Zetetic Astronomy, Worlds Beyond the Poles, that's Infinite Planes, all those works are fantastic and great works, great starting point. Here we are to 2017. We have more technology. We have more understanding of things. And, has anybody heard of a girl named Cindy Holland?
Yeah, we know Cindy.
Yeah, you know Cindy. Well, I got her on my Skype. I've been talking to her. They did an article on mail.com or some UK big news thing they did on her. And first of all, they claim NASA admits that all their things, most of their things are CGI and fake anyways. And so that was kind of a cop-out on that part, because NASA does actually, but everything NASA does is fake, even the stuff they claim is real. They didn't mention that, but they attacked Cindy and these other women based on, these women think there's an ice wall circling Earth. And every attack and every angle I get on my channel comes from the point of the azimuthal equidistance or projection type map. That's the attack. And that is, I believe, was designed. I believe the UN flag that was broken up in those 33 degrees. I believe that they have taken the old Zedic astronomy when they realized flat Earth was coming back, and they force-fed us back the map that they know is wrong. And of course, we ran with it because that's what they were looking at way back when they did have some a lot of valid observations concerning the Earth not being a sphere. But now they didn't expect people like us getting together and say, hey, wait a minute, we're comparing scriptures, we're comparing other ancient works, and we're looking at the aether and electromagnetics that possibly explain that why the Earth is actually square, the UTM grid is correct, and the UTM grid does not work on any projection map, so I don't know how you figure your GPS works if you don't believe, if you believe in that map. And now we're figuring it out.
Exactly. That's why I try to explain repeatedly. I tell people, I'm like, look, you can't convince me that every single pilot in the world is in on the secret to hide flat Earth. Not a one of them know this secret, I guarantee. Now, if before we had GPS, I'm talking about, if they're taking a paper map out, they were taking out that square UTM map. At no time did you ever see a pilot pulling out an AE map. They've always used that square map. To this very day, if you go to any airport in the world, as soon as you walk in the front lobby, you're going to see a gigantic billboard of the world map in every airport. It's going to be a square Pac-Man style map. Usually they'll have like half of Europe will be on one side and Russia will be on the other side. The United States will be in the middle. Well, we know Russia and Europe are not two separate continents. That's all one continent. So what's that telling? For one, we don't circle around the North Pole, Central North Pole. And for two, they're telling you they're showing you the Pac-Man nature. They're saying if you leave the United States and you go you go east, you're going to come up on Europe. If you go to west, you're going to come up on the opposite side of Europe. But, you're still going to the same place. So they're showing you that Pac-Man. The same way with military maps. You got a soldier who might not have GPS. He has to use a paper map. He might not even know where he is. And he's been taught how to set up a square system, a square grid system. Their map is a square UTM. These soldiers that depend on, they have to know exactly where to bomb, where to send their troops, where to send this or that. They have to pinpoint that stuff with accuracy. And before we had satellites and GPS, they were using a square map. No one uses an AE map. No one has ever used an AE map. I was looking up the patent today, as a matter of fact, now I was reading through it, and it tells you right there in the patent that it's a time device used for telling you where the sun is. That's it. It's not a land navigation device. It doesn't say latitude and longitude. That's why the squares at the top of the map are so tiny and the squares at the bottom of the map are so fat. And what I try to tell people is like, look, I know the Earth is not a ball. However, you can't convince pilots for 500 years that the Earth is a ball if your mathematics don't work out. My point being is the ball math has to work. Obviously with slight fluctuations, obviously. And my point is, unroll that map. Do not get around AE map. Get a square Mercator map. And like I said, if I can take that map and I can navigate to anywhere in the world and not get lost, how is the world not square? I'm sorry. I'll tell you what, here's a way anybody out there, if anyone out there has any question, you don't have to know math. Here's what you do, guys. Anyone that's listening, get two maps. Get a round decent map and get a standard square map. Drive down to your local airport and just stand in the lobby and ask a pilot, hey, if your GPS turned off, which one of these maps would depend on to get you across the Atlantic Ocean? And then ask them, why wouldn't you pick the other one? Right there, you're going to have your answer. Let the pilot tell you. He's the one that flies it every single day. He's not going to lie to you about it. He's not part of the Illuminati or the elite that's out there to hide the flat Earth, man. The guy's just going to tell you what he knows. He's going to pick that square map. The Earth is square, folks.
Right, and you're right. If he was out in the middle of the ocean, the only projection map that'd work for him is a projection from his location, not from the North Pole. That's the only projection that would work for him. So he's going to pick the square map every time. And NASA, all their FTP servers, every map NASA uses is the Mercator projection. That's the only thing our government uses. And It's right in front of us. What they didn't count on us doing is figuring out that the fact that it portals.
Right.
That's what they were counting on.
And you know what? And they're right, though. That is our biggest problem. That's our biggest obstacle when it comes to explaining. Because, you'll see a lot of trolls. They'll pull up on the AE people, and they'll just destroy these guys. The AE people don't realize they're being destroyed with actual facts 9 times out of 10. But when them same trolls turn around and find out that you're a square earther, they're nowhere to be seen. They're gone. They don't waste their time because they only have one possible thing to argue about, and that's the nature of movement, the Pac-Man effect. Outside of that, every single thing, every one of our cities lines up. If you get a list of every single international airport in the world and map them out, the distance between them all, it lines up perfect with the TM square. We have a perfect map. We can explain everything except for that. That's the only thing we really can't righteously explain.
But we have pilot testimony of it. I have video of it, of the double sun. We do have proof. And the thing is that 90% of the map also explains the ball map, or the ball. Okay, and this is why flat earthers are getting eaten alive and can't answer the questions. And you're right. When I get trolls on my channel and says, well, what about your ice wall? What about I can take a flight to San Pablo to Van Halen Islands?
Yeah.
And what about that? And I tell them I don't support the AE map. Okay, and that's it. I don't hear another peep out of them.
I don't think we can write off any map yet. I think we got to go down every single road and test everything. I don't think you can just write off something.
I think you can write off the AIM. I think you can write off that map 100%, because, like I say, this like once you get past that equator, there's so many problems with it. Like I say, flight routes.
I'll just say, Stan, that when I met Dave, the whole reason I did the moon race was to prove it was real, and it didn't. It proved it was wrong. The real sort of AIM map.
No, it's proving the model's wrong, but there could be something to the actual map.
Well, here's the
The
thing,
model
though,
itself is wrong. Yeah, I agree.
Here's the thing. If you look on a ball, the ball tells you that if you divide your ball up with the equator, the north and the south both have equal area. However, on the AE map, the south has almost 5 times more area than what the north has on it. And that's the big problem, because when you smash a ball down, you're not realizing how much space they're actually creating when you smash that ball down. And all they're doing is drawing a giant circle around it and filling in all that empty space with a blue marker and saying, oh, well, this is ocean water, and the planet, or the continents are just a little bit bigger down here. But you can't smash a ball. That's not how it works. You have to cut it down the prime meridian and unfold it that way. That's the only way you can unfold a ball.
Yes, and commercial planes don't fly at Mach 1. I don't care what they say. I don't care what air current they'll fly on. They're not going to be flying at Mach 1. A 777 is not going to be flying at Mach 1. It's impossible.
Oh, no, I agree, but all I'm saying is that you just cannot write off any path. You have to go down it and test it to then write it off. You can't just say it doesn't work.
We did.
Don't match anything but the square, because it's the original data, and the photograph is for me the empirical proof.
Oh yeah, it could. That map though could be a square, so it might hold some truth. That's all I'm saying is that.
Right.
Well, Stan,
I'm not saying it's right. That's all, but I'm saying it's something we have to definitely look at. To me, the AE map depicts time. It shows you what the sun's doing around you. The time basically.
Right. That's exactly what it was designed for. Gleason put that in his is so that, because when you're at sea, you don't navigate by land. You're navigating by the luminaries.
Yeah, you use the stars. They always have done. They've always used the stars. So
right, that's the whole point. That was the whole point. Because if you peel a map, I wish I had this diagram that shows when you peel a map off a ball, and it makes these points at the north and south, and you have 10 points at top, 10 points at the bottom. And it shows how if you pinch all the northern tips together, it twists the map around to form the circle AE map. But when you pinch all the northern tips together to make that circle, all the southern tips spread out and create too much area. And that's the problem. We have to be able to count whatever the map is, and I'm not saying exactly. I know it's the square style, but yeah, I'm not discounting any particular map, but whatever the map is, it has to match. It has to be able to account for every piece of map that we find on the ball.
I agree. That's what I say. Like, we can't just write it off. There's truth in that map, but we need to basically take everything, look at it all, rip it apart, and put it all back together with something that is reality, what we're seeing. You know?
Well, I think with David talked about airplane.
And I expected to have, actually.
It's like me and Z Proxy were talking last night, and we were saying, you know, if you took two 360 cameras and like put them at their GP coordinates, so they were like back to back on the globe, so to say, you know, on their ball. If you put them back to back, and then what would we see in the sky? Would we see a big gap where we're missing something that they're not showing us? Or
the only thing I can say is the sky and the land are not the same.
No, they're not connected. I agree. The only thing that ties the sky to the land is you, from what I can see.
Yeah. We are in between the two.
Mm.
It seems that the land is square, but everything else is circles. Toroidal fields, perspective bubble, our eyes.
They're two separate things,
else.
you know. The land and the sky it's basically like the land's flat and the sky's a ball.
Yeah, that's what a lot of flat earthers have a problem separating the actual terrestrial from the celestial. I try to explain this like by saying that celestial phenomena is measured in declination and terrestrial is measured in degrees. That's the difference between the two. You know what I mean? And it's quite difficult when you're referring to poles. They're like, what do you mean poles? Well, they're thinking of terrestrial poles all the time. And like I say, it's knowing the difference between celestial and terrestrial. Like I say, that's what I think a lot of the problem is as well, because they think you're referring to actual geographical poles when you're actually referring to celestial. And even when you explain to them that, I don't think they get an understanding of it. And I think that's one of the major problems.
No, that's it. There is two celestial poles, but there's not necessarily two poles on the ground, you know.
Well, I don't
know. But that's why Siri...
on the land we have four pillars, so that's also...
Yeah, I can answer that.
Well, I'd like to sit down with you one night as well, series, and we have like 3 maps out, you know, like a globe, the AE, and a square map, and we can plot that navy tracking and just see like if we can paint a bit of a picture, you know.
Well, they use the UTM, so I think you'll find that's what it'll match up to.
Yeah, but when I plotted it with another guy, Brian, we actually, because I've got my tracking, so I know what mine's doing, so I plotted mine, and then we plotted it in South Africa as well, and then you can then work on, like, we've got someone in Guam, Raven Locks, she's joining us doing some moon tracking, and yeah, so we'll be able to put these points and hopefully start painting a picture, you know.
On the terrestrial north and south poles, and terrestrial means earth or ground, on the ground, physical stuff. There's nothing that crosses center of either pole. On the celestial, we see a magnetic field outside of Earth that is toroidal, and that means just circular. Okay, for those who don't know what toroidal is, we see those types of things working concerning the stars and everything else in the magnetic fields. Even NASA shows this. But ground-wise, nothing crosses center, north or south pole. And you know, I'd like to get a plane over one of those and see what the heck's going on either pole.
I think many would.
Can I just say, Stan, I don't know whether you're aware, but our group, Sun and Moon, have 10 months of world compass readings, tracking the sun, the moon, Polaris.
Yeah, I've seen it. That's why I was sat there that one night when I first joined, and I see that, and I was like, damn, these lots, like, they're there, you know. We just need to put it all together. We just need everyone to come together, work all through it. You know, it's not going to happen overnight, but it will happen. I can see it.
It is happening.
Yeah, especially with, like, you know, get Chris's drone built and stuff. We'll have a lot more.
Oh, just to let you know, Stan, we're having a bit more of a drone talk. We've got David James coming on Thursday. Maybe people don't know him. He's still a member of Sun and Moon. He takes a lot of pictures of distance things.
He's been filming the sun quite a lot lately.
And what it is he's coming on to talk a bit. He'll probably have a few little videos. And then after that, we're going to have Jeremiah on again to talk a bit of drone stuff. So I don't know whether you want to join us on Thursday, Stan, with drones.
Yeah, if I'm here, I'll jump on. More than happy.
Yeah, put your name down for that one. Just to let everybody know that we have sort of been going now for nearly 4 hours. Do you want to carry on for a little bit longer, or do you think we've talked enough today, guys?
To be honest, I should have come off about 50 minutes ago. So I'm gonna have to get off because I've got to get up and go out early in the morning. But it's been great speaking to everyone.
It has.
If anybody wants to get hold of me, just message me.
Does everybody want to stay on for a bit longer, or do we want to sort of end this hangout with Dave? Just asking everybody on the panel.
I'm good, Karen. I got the models to make and figure out how I'm going to show what the moon does, since I was completely wrong on my other video. So
yeah, you should check out Z Proxy's model that he's done. You really like that. You should all of you really should get some VR. If you have the Samsung S7 with the Oculus, we can build from the 360 cameras virtual model of what we're looking at, and as we move around, we can move the sky to work. You know, we can make it work.
Yeah, they do look pretty special then.
Yeah, but you only be able to view it in the goggles, you know. But then we also need the 360 data to back up what we're doing.
Can't you use the Google Cardboard for the same effect?
You can, but it's not like what we're doing is you can't really do out the box, you know. It's all prototype stuff, so really you do need an S7 with the Oculus to be able, so we can just send you and we know it will work, you know.
Yeah.
But you can buy the phones now, they're quite cheap. You can get a refurb phone, and I paid £25 for my Oculus second hand, so
that's good.
It's not
the Galaxy phones aren't very cheap though.
Yeah, just keep looking around, you pick up deals, you know.
Yeah, right, I'm gonna have to shoot then, guys, anyway. Nice speaking to you all.
Go with Dave and end this hangout, because we've been going for nearly 4 hours. Just wondered if Trisha and back, and we have our last group hug. We've got to have our group hug.
Just one thing, will somebody maybe just give me a rundown how to do a hangout screen share next time, because I'd really like to know how to do it.
Check out Chris the Truth Seeker.
Chris the Truth Seeker, right, I'll check it out then.
Yeah, go on his channel, he's
Chris,
got loads of good stuff.
Mike, Trisha. Oh, he's gone quiet. Mike, he's turned his microphone off now.
I'm in the dark, but I'm here. I'm in the dark. Yeah.
It's Trisha.
Right then.
Well, maybe Patricia's fallen asleep, and Stan and Turquoise prefer their.
I'm here.
She's right
I'm here. Can you not see me?
Now, Stan and Turquoise Dragon prefer not to have cameras on, but we've come back because we're all going to have a group hug. That was a really great discussion, great with Mark Sargent and everybody else on the panel. And I don't know, do we have a hangout on Monday next week about the Eclipse series? We just have to go on Monday, won't we, as a live hangout as the Eclipse is happening?
I guess so, yeah.
Yeah, I'll be shooting it live anyway, if I can catch that back end of it.
Actually, locally.
Yeah, I might end up doing it, like joining live. I'll be out filming.
Well, we'll just share your feed. We'll share your feeds on our live hangout, and we'll be talking in the background. But thank you so much for everybody, and we're having a group hug for everybody on the panel and everybody watching and everybody in the chat room. Thank you so much. We're back on Thursday, so we'll see everybody on Thursday, and thank you so much for watching.
Bye.
Everybody say goodbye.
Thanks, everyone.
Hang on this. Everybody say goodbye. Thank you.
Bye, everyone.
Bye.
Bye.
Somebody is echoing.
That's it. Ooh.